Matimulani, and I will be chairing the session, joined by Lesego Munyai as our technical facilitator. And I'm delighted to welcome you all to today's session. We are in track C, Introduction to SPSS, and thank you all for being here on time. And I hope you are bringing in your enthusiasm and curiosity, and whether you are new to SPSS or you are just looking to sharpen your data analysis skills, this session by Dr. Gordon promises to be valuable and a step forward in many of our journeys around data analysis. Just in terms of housekeeping, today's training will run for around 4 hours with a 30 minutes break halfway through the session. And we have Lesego manning our technical queries. Colleagues and participants can write their comments in the chat, the tab, and we will do our best to bring them to the attention of Dr. Gordon, who will be our presenter. And it's my pleasure to actually introduce our presenter for today, who's Dr. Stephen Gordon, a Chief Research Specialist within the HSRC in Pretoria, in South Africa, I meant to say, with over a decade of experience in social science research. He specializes in survey-based methodologies and has contributed extensively to the South African Social Attitude Survey, what we call SPSS, over the past 12 years. And Dr. Gordon holds a PhD in social science from the University of KwaZulu-Natal and master's degrees from UKZN and University of Vryburg. And he has authored over 40 peer-reviewed papers, so I think we're in good hands. And over 29 book chapters with significant involvement in policy making through research reports and briefs. And of course, Dr. Gordon has been recognized by the NRF with a Y2 rating for imaging scholars, researchers in the country, and has extensive experience in project management and interdisciplinary collaboration and mentoring of junior scholars. In today's session, Stephen will guide us through the essential of SPSS, from introduction to SPSS to navigating SPSS interface, entering and cleaning of data, importing Excel data, and of course, he'll also touch on descriptive statistics, visuals in SPSS, and inferential tests in SPSS. And colleagues, without much further ado, I would like to welcome Dr. Stephen Gordon.
Thank you very much.
Thanks, Stephen.
That was a fantastic introduction. I'm looking forward to speaking with all of you for this morning on the important topic of SPSS. So this will function as an introductory course to SPSS. We're going to talk a lot about intro statistics. So we're just going to go through the software package, and we are going to discuss in a lot of detail how you do the basics in SPSS. So for all of those who are new to SPSS, this is going to be very, very helpful to you. For those who've used SPSS for a long time, I'm not sure how helpful this will be, but we will do our best. Okay, so I'm just going to share my screen, if that's okay with everyone. Okay, just hold on. Okay. All right, so I just want to get some confirmation that everyone can see my screen in front of me.
Yes,
Yes, we can see it.
Perfect, excellent. Thank you very much. So this session will hopefully provide you as young and emerging scholars with all the information you need to start your journey as people who do social science research. Now, very importantly, this session will be looking at SPSS, but a very specific version of SPSS, which is SPSS 29020. Right. So it's very important to remember that SPSS has many, many different iterations. It really started in the 1960s. So very, very key here. I just want to let you know that different versions of SPSS will have different criteria and therefore demand different types of skills and different types of user interface. Just be aware that this training session is very specifically for SPSS 2902. Okay. So, what are we going to do in this training session? Now, I'm just going to give a little background on how SPSS training is normally done. So normally with SPS training, you have a small classroom of people, you hand out data sets, and then people spend time slowly going through those data sets. But as you can see here in front of us, we have a large number of people in the room with us today, and as a result, it's not always going to be very easy to go through data sets with such a large number of people. You really need that personal one-on-one connection. So what we're going to do is we're just going to go through each stage of the data usage process. We're going to go through it very slowly because for a lot of you, this is quite new and it's a little complicated. And so very, very key is we are just going to make sure that every step of the process, you understand what's going on, what's required, what's needed, and we will stop, we'll get questions, we'll talk about feedback, and we'll just make sure that we don't lose anyone as we go on. Now, the goals of our training session today will be to navigate the SPSS interface confidently and effectively. We're going to look at how to enter data manually for those of you who are conducting primary research. Maybe you have a survey instrument for your studies, or even if you're part of a research project, it's often necessary to manually enter data. Then we're going to look at performing basic descriptive statistics. Very, very important, but nothing too complicated. And then we're going to conduct some simple correlation tests, looking at the correlation between two variables. And we're going to stop and talk about results at each stage of the process. And we're going to stop and talk about how we interpret the results that we have at each stage of the process. Okay, so whenever you open up SPSS, you're going to really see this screen right here in front of you. So on the left-hand side, there's the data view, right? So this is where you enter in or view data, right? So if you have data from a questionnaire that you've been filling in, raw manual data, this is where you would enter it in. And then you have your variable view. Now, variable view is when you define your variables. So in variable view, we're going to look at how do we create variables. Very, very important. And then once we've created variables, we can look at them in the data view. And then, of course, there'll be lots of manipulation of data and analyzing data. Okay, so let's move on to the next slide. Entering variables into our data sets. Okay, so in any data set, we need to enter in our variables. So where do we begin with this basic task? So firstly, we have name, our name column. So here this is the name of the variable. We want a short, clear name, right? Not too many spaces. Usually they are very simple and straightforward: age, gender, income, etc. Then we have type. Okay, so data comes in different types. There are usually mainly two types of data when you enter data into your box here. So the first one, and this is the one that's going to come up most often, is numeric data, right? So that's numbers 0, 1, 2, 3, 4, 5. All right, and then there's string data. So string data is text. So often when we do a data set, we will have both open-ended qualitative questions in which people can write in a very specific answer to a question, and then we will have numeric. So people will write in a number. Now, when it comes to numeric data, there are two different types of numeric data. So the first type is continuous numeric data. So continuous numeric data is used for variables like age or income. Right. So age 0, 0 to say 100 or so. And then income would be say 100 Rand, 200 Rand, 300 Rand, 400 Rand, 500 Rand. Right. Now, the second type of numeric data is categorical numeric data. So when we have a categorical variable, we assign different categories a number. So the classic categorical variable is gender. So I'm sure many of you have filled in a form before and therefore are familiar with requests to fill in gender. So usually, historically, gender has been filled in a very binary way. So 1 female, 2 male. Now, recently, there has been a move to expand the number of options for gendered identity. And usually people add multiple different gender identities under this categorical column. Now, it's become standard practice to add a third category, say other, for gender, but you, depending on your research needs, may want to add in multiple ones. So that is a what we call a nominal categorical variable, right, which we would label as numeric. Then there is other types of categorical variables. So the other type that's most important is an ordinal type of categorical variable. Now we'll talk a little bit more about this as we go on, but let's just mention it here. Very, very important. So an ordinal type of categorical variable is a categorical variable which has a high and a low category, right? So how does this work in practice? So in practice, you would ask, do you trust or distrust the national government? And then you would read a list of different responses. So we start with strongly trust, trust, neither trust nor distrust, distrust, strongly distrust. So strongly trust would be your high. So usually we put that as 1, and strongly distrust would be low. We usually put that as 5. And so each of these ones would be assigned a value. So we're going to get to that, but I just want to bear those differences in mind. Okay. Then we get to your label column. So in the label column, we want to write a descriptive label of our data. Now, normally, This descriptive label is the question that the data is speaking to. So, for example, age, right? Now we can write respondent's age, which is normal in any type of questionnaire. We can also write the full question. You know, please state your age in completed number of years. This is more normal. We can write really anything in there. Then we use the measure command to define the type of data. So I just want to So the measure command, this little box comes up there. Now this is the categorical stuff I was talking about previously. So a standard categorical variable, gender. Now traditionally gender again has been labeled in a binary fashion, one male, two female. Of course, in these more enlightened times, we use multiple types of identity markers here. So depending on the needs of your research, you can add as many categories as you like. Now, when it comes to creating variable labels, it's very important to think about both the responses that you're going to get from the field, but also the non-responses you're going to get from the field. So you got to bear in mind that there will be missing data. So missing data usually comes in the form of two types of missing data. So one is don't know, and then the other one is refuse to answer. These are two different types of non-response, and they measure two different types of responses, and therefore should be captured in that fashion. Okay, so again, satisfaction data, satisfaction categorical data from 1 to 5, right? What would that look like? So usually we would ask, are you satisfied with, let's use an example here, how democracy is working? Give strongly satisfied, satisfied, neither satisfied or dissatisfied, dissatisfied, strongly dissatisfied. So we have 1 to 5. We can label them in whatever order you feel is necessary. And then, of course, we're going to add in our missing variables. Okay. So what does this all look like in practice? Okay. So in practice, what this is going to look like is you're going to have in the one column there, you see name, lots and lots of different names that you're going to have. Usually, again, you see short names there. There shouldn't be any spaces between the names. So if we want to create a space, for example, population group status or class status or economic status, we usually use a underscore between the name and the other variable. Right. Okay. So this creates for you very nicely a set of variable names. Very, very key. Then we see their type. Now, because all our data is numeric, indeed, most of the data you enter into your data editing window will be numeric data because quantitative data is designed for the analysis of numeric data. So most of this type is going to be numeric. All right. Then we have your variable name. You can see variable names there. What is your age? What is your sex? What is your marital status? Etc. etc. Very simple, very straightforward. This is very helpful when you want to share your data set with people because they don't really know what your different data labels mean often, and it's very important to have this description. Okay. Then we have missing data. So missing data is the what I was talking about before, right? Are there data that's missing, right? Missing values in your data, right? This is data that has been classified as missing. Usually it's because the respondent in some way has refused to participate or has simply not answered the question. Okay, then we get to our measure. Now remember we talked about measure a little bit before, but let's go through it in more detail now. Okay, so let's start with something very, very basic, which is nomial data. So nomial data, a nomial measure, is simply categorical data which has no order. So you think about something like gender, right? There's no order between male, female, and some other type of gender demarcation. Okay? Or think about colors, red, blue, green, white. They have no intrinsic order, right? One is not higher than the other. Then we have ordinal data. So ordinal data, this is what I was talking to you about before. This is usually data that we placed on a scale of some type, right? So it usually goes from a high of say 1 or 0 to a low, and then this can be as low as you want to go. Usually it's below 10 for your ordinal data. It really depends on the type of data you're working for. And then we have our scale. So scale is for continuous data, right? So continuous data is data that is not assigned to a value and can go from 0 really to any upper benchmark, right? So a classic example of a continuous scale data is age. So age can, a person can be any age, really, and we do not assign categorical variables to age. All right, so let's talk a little bit about some of the tricks of doing this type of analysis. So you can copy variables from Excel into here, right? This kind of really helps if you have an Excel document that you're trying to enter in to a data editing window in SPSS. So you can see there's these your data labels. You can just copy and paste it from the Excel spreadsheet into here. Very, very helpful. Don't need to enter it in every time. It's quite straightforward. Okay, so what are some of the other things that we can see in the? Oh, sorry.
Sorry, it's Lelo here.
No worries.
Your slides don't seem to be moving, so we're not sure what you are referring to.
Which slide is showing in front of you now?
It's the slide with the heading numeric default used for numbers. If you are using the same slide, we are not seeing where you are pointing. Sort of your cursor is not showing. Yeah,
Oh, okay. No, I wasn't really. We're still on this slide, the numeric string data.
yeah. The cursor is not moving just to point
Oh,
to.
sure. Okay.
Uh,
All right. So can you see my cursor now?
yes.
Okay.
Yes.
All right. So,
Yeah. Correct. Thanks.
okay, here, let's just go through this because again, this is quite important. So here we have our variable labels. You can see them in front of you, right? So this is a full description of the variable. Usually it's the variable question. Right here, this is type. We talked about this already. So there's different types, numeric, string. All right, there's one thing we haven't talked about. It's dates. This is usually quite important if you want to give the dates of when the interview began or the dates of a very important event that happened in the respondent's life. But it really depends on what's going on in terms of your questionnaire. And then, of course, there are string variables, again, for text data like names and what have you. Okay. And this is measure. We talked about this. So you normally have ordinal, numeral, scale, etc. Okay. A lot of these other ones are not going to be very necessary for you to work with, so I wouldn't worry about them. You can get quite lost in the weeds with these things. So I wouldn't worry so much about this, the rest of those columns. Okay. So let's talk about entering data into our data sets. Right. Okay. So in order to get this screen, we need to have already designed all our data. Okay. We need to have designed all the variables that we are going to be entering into the SPSS data sets. We need to have designed their nature, and we need to have, if they're categorical variables, assigned values to those categorical variables. Okay, so then what we're going to do is we're going to go to the data view screen, and in the data view screen, we're going to see all the variables that we just designed, and then we're going to be able to enter in the data for those different variables. Okay. Now, what that looks like in practice be something like this. So the actual labels and the numbers assigned to those labels are not important. This is just an example. Okay. So let's go through it very, very slowly so we all understand kind of where we are in terms of this. Okay, so firstly we have the columns. So our columns here are just the variables that we previously constructed: age, gender, income, etc. Okay, then we have our rows. So the rows are the individual cases, right? So they represent the individual, usually we work with questionnaires, so the individual person in this case, right? Then each variable will have a different criteria for entering in data. Okay, so numeric variables, right? Those you enter in the number assigned to that variable. So age, for example, so you would enter in the numeric age of the individual, say 23. Then there is something like gender. So here, gender, we've assigned labels to numbers. So 1 for male, 2 for female, etc. All right, and we can see that there. Then there are, of course, string variables. Normally, we don't do string variables in a quantitative data set because it's not ideal for analyzing string, but you can have textual data in here. You would simply assign a variable for the textual data. Okay, so very important here is when entering in our different variables, right? We need to watch out for inconsistencies, right? Unexplained variables, blanks, etc. Okay, so you can see here that some of the boxes, right? They are empty. These are empty boxes. They have missing data in them, right? So usually when we have missing data, we want to assign it a value, right? So if our missing data is assigned the value of, say, 99, we want to enter it in there. Okay. If there's data that doesn't really make sense, then we also want to make sure that we are analyzing that data in a proper fashion. So if there's like an outlier, if one of our age categories is say 200, we want to check that case and make sure that it is, that it's the right variable for that data column. Okay. So this is how to manually enter into data into SPSS, right? Now, sometimes what we're going to do is we're going to import data into SPSS. And when we import data into SPSS, we are going to have duplicate data. So duplicate data is a bit of a problem. This especially comes up if you're working with large data sets. So we need to look out for and test for duplicate data. So this is going to be part of your data cleaning process. So data cleaning is a crucial step before any type of analysis. It ensures your data is accurate and consistent, and it can be used for all your different types of statistical tests. Now, very importantly, so I want to talk about duplicates. So I did mention duplicates earlier. So duplicates are quite a bit of a problem, but SPSS has this system that allows you to look for and find duplicate data, right? So if you just go to your data window, you scroll down, you can see you can identify duplicate cases. Now, how do we identify duplicate cases, right? So this little window is going to pop up. It's going to have all the different variables that you've created in your data set. Now, one of the most important variables is something called ID. So ID is the unique identifier number that each respondent in your data set should have. Now,
Dr.
oh yes,
Gordon, sorry to interject. May you
sure.
please use the laser pointer in the presentation tools?
Oh, okay. Hold a second. Where is
You
the...
can find it down there on your left, where it's like a paintbrush. You just click on it and then you select laser pointer.
Good. Annotate, spotlight. Is it this?
Yes.
Oh, perfect. Okay.
Yeah, it's that, sure.
All right. Okay. Here we go. Oh, no. No, it's gone away again. Okay, hold on. There it is. Right. Okay. So, ID. Right. So, each person in your data set should have a unique ID number. And what you do is you move that from your window here to your define matches by column, and then you press OK, and then it should come up with this at the bottom here, and this at the bottom shows you if there are any duplicate cases in your data set. And if there are duplicate cases in your data set, then you can go back to your full data set, find those duplicate cases, and remove them. Right, so that's quite important and quite essential. So I just want to talk a little bit about, okay, yeah. So sometimes you will enter data into SPSS manually. And I've just talked about how that's done. And it's very important you understand how data in SPSS is manually constructed, right? But then often what's going to happen is you're going to have data which you have to import into SPSS. Now this is quite easy. So what you do is you go to your file, it's a little corner of the screen there, you go down to import data, and then you select Excel, and then a little window is going to open up and you're going to find the very specific Excel file you want to choose. You're going to select that file. You're going to open that file, and then there's going to be import options in that file. Right. Okay. And you're just going to select the worksheet, very importantly, in the Excel file you want to import across. You click OK, and then voila, you've imported data from Excel into SPSS. So when you do this, there's a few things you want to really do. So you want to check your Excel file, right? You want to make sure it's properly cleaned. SPSS does not like non-numeric characters. So please make sure that the file primarily contains numeric data. You want to avoid blank rows in your Excel file, right? Or blank columns. Make sure all the data is entered correctly according to your needs. And then you need to check the variable view to ensure that the SPSS is assigned the data that you've imported correctly. So I've given you a very brief overview of importing data into SPSS. It's like this. You see that I've used this spotlight thing. Usually don't use this, so this is quite unique for me. So I just want to take a little bit of a pause here and see if we have any questions about importing data into SPSS. Because it's quite important that we get this part of the data entry process correct, because when we start working with the data, it's going to be very, very important to understand what we're doing and, of course, why. Okay, so
Doc,
I am
Doc,
going.
Hi.
Oh, yes?
Doc, I'm asking, what
Yeah.
do you mean when you say you clean your Excel sheet first?
Right, yes. So this is very important. Okay, so I don't know. So I was going to ask the chair to assist me because I'm not sure. Like normally I work with Teams and there's like a whole hand raising system in Teams,
Yeah.
but this of course is Zoom, which I know is a little different. So I will ask the chair to assist me. I see people are raising their hands. Excellent. To assist me with the fielding of questions to make sure we're not missing anything out. I encourage you to raise your hand. I know there is a chat window. And if anyone wants to put things in the chat, I might not be able to check those. So please, if we could just raise our hands, answer questions. But I asked the chair to assist me here. So,
Yeah. Hi, Stephen. We actually have Lesego manning the chat
oh,
and
perfect.
keeping track of the questions. And if we
Excellent.
don't have questions in the chat and you open the space, we'll take hands from all the participants. I think we have a number of questions. Lesego can go ahead and read those for you, and you respond to those. And if there are none, we'll take. I think Israel has a hand up. So let's start with the chat, Lesego.
Okay. So let me just talk to the first person who asked the question, and then we're going to go to the chat. Okay. So I'm going to use. So it's often best to use examples of how this is done in a very practical sense. So let us say, for example, you have a research assignment, and your research assignment is do 150 questionnaires with people about their health and economic status. So you go to 150 households and you talk to 150 people and you gather all your data, right? And you input that data onto an Excel spreadsheet. So an Excel spreadsheet, as we know, because I'm sure we've all worked with Excel before. So we have different columns, A, B, C, D, E, and then we have different rows, right? So when entering in your data into an Excel spreadsheet, you really want to think about how this will look in SPSS. So your different rows should be your participants. Hello. And the different columns should be the variables. Right. So how would this work in practice? So let's talk about this very slowly because it's very, very important. So I have the first person who's filled in a questionnaire. I put the questionnaire down and I want to enter that questionnaire data directly into the Excel spreadsheet. All right. So row 1, I'm going to have different columns in my row. So it's very important I have an ID column. I put ID and I assign that first questionnaire a ID number, let's say 1. And then I'm going to have different columns for all my different variables. So let's just use a few examples here. So say I have age. So I'm going to have an age column and I'm going to put 1 or 6
Apologies
or
to
12 or
interject.
56
Sorry, are you by any chance?
in the column. Right. So based on that, I'm going to then, once I've done that for all the columns, I'm going to import that data into SPSS. So when I have my Excel spreadsheets, before I import it into SPSS, I need to check that I've done all those different steps correctly. So have I assigned all the columns correctly? Have I assigned all the data that are supposed to enter into those columns correctly? Are there the correct number of rows? If I have a column which is just for age, you shouldn't really have any text data there, like, the word red, for example, shouldn't appear in that column. So that's really what I mean about cleaning the Excel file. Now, if your Excel file is not clean, you can clean it when you import it into SPSS, just like I've talked about, but it's gonna take a little longer to do because SPSS is more for the analyzing data. And often when we have lots of errors in how you've entered in data, it can be a little tricky in SPSS to really weed that out. On the other hand, if your data set is very, very large, SPSS possesses a lot of data cleaning tools that are really going to assist you in this area. So that's very, very important to bear in mind. If you have a large data set, you really do want to try and clean it with SPSS because trying to clean it manually using Excel just takes too long. Okay, so I hope I've given a comprehensive enough answer. Let's turn it over to some of the other people who have questions.
Dr. Gordon, Aneli is asking how you clear or remove a row if there's an open row in your data.
Right, okay. So if there is, so say for example, you have a data set. So we talked about this before. You've entered in 150 entries into your data set according to very specific questions that you've asked in your questionnaire in the field. Right. So now you have all your cases lined up in rows. All right. So all you need to do here to remove a specific case is you just need to delete it. So just like with Excel, you select the case and you have it removed. And this often will happen if there's, for example, a duplicate case in your data set? All right. I see there are some other hands.
Thank you. There is a hand from Israel.
Oh, hello, Israel.
Hello, Stephen. Thanks for the presentation, and also morning to you, or good day to colleagues as well. I think part of the challenge we are facing is that as you seem to be demonstrating, but we can not actually see the demonstration. But I think we will get to understand as you will move on to maybe there are other aspects that will make us at least become part of what you are doing. But I think you also touched on the question that I wanted to ask partly, because I wanted to ask what should be the properties of the Excel document that one can import into SPSS. So I think you ended up talking about what should be on the rows and what should be in the columns. Maybe if you can just quickly touch on that, because I'm thinking what one must be able to capture in the Excel so that by the time that they import into SPSS, it makes sense. Thanks.
Okay, so here we can see an example of data that's been entered into a series of rows and columns. So what's your Excel data set is going to look like is kind of going to be, it's going to look like this, right? You're going to have a column, say age. It's going to go from one, your first row, all the way down to how many respondents you have. Each row represents one respondent or one case. We call it a case. And you're going to enter in manually numbers in this column. Then when you import it into SPSS, it's going to look exactly like this, right? Because SPSS uses an Excel format to analyze data. Okay. Yes, I see. Let's go to the other hand there.
There is a question in the chat box
Oh,
from
sure.
Yamkela, and they're
Mhm.
asking how do you download the SPSS software and if it requires to have rights or a license.
Oh, okay, sure. Right. So your organization, whether it be a university or a research institution, will provide you with SPSS because SPSS is not free. This is not a free software. It is a subscription software. Now, if you would like, you can download a free version of SPSS and use it for a very brief period of time. But then once that period of time has lapsed, then you will not be able to use SPSS again. So it is a conscription model. It's very, very important to understand. And your institution will usually provide you with that subscription.
Thank you. There's a
Okay.
hand from Fahima.
Yes,
Hi, Lizzo.
hi.
I think it's an old hand. Stephen, quick one, what we are picking from
No, it's not
the
an old hand.
Oh, okay. Go ahead, please, Fahim.
Hi, yes, just also on Israel's point for going forward, if there's another screen that you're working on, to please maybe show us that so we can work in tandem. And then second, I have another question for the SPSS program that we are advised to use through our universities. When we are creating the questionnaire, do we use a Microsoft Forms as one of the avenues that we can update, or do we have to do it on Excel, or can we use Question Pro, which is also affiliated with the university? That was my question. Which document do we use before we upload onto SPSS? Thank you.
Okay, so you would use Excel. So Excel is the primary data set that you would use when uploading data onto Excel. So you wouldn't use Word at all, you would use Excel. So if you think practically about how this, say you're collecting primary data, you would design your questionnaire in Word, and then you would print out that questionnaire. You would go to the various people you wanted the data from, and you would fill in the questionnaire manually on that piece of paper. Then you would go back to your computer, you would sit down, and you would manually enter in the data into, say, for example, Excel, and then you could import that into SPSS. Alternatively, you could have an Excel data set that's provided to you by someone else and then import that into SPSS. Or you could have raw data. We talked about these questionnaires that you filled in. You could sit down and you could manually enter those into SPSS. Now, if you're working with a large research company, then you probably will have access to a data capturing software, and this will, this data will be automatically uploaded to a digital suppository, which therefore can be downloaded in different formats, one of those being Excel or SPSS, the .saved file. Okay. So are there any other questions? I see there are.
There's a question from
Oh, yes.
Nancy, and
Okay.
they're asking how if you remove or clean data, how does it affect the reliability and validity of the data?
Okay. So let's just talk a little bit about cleaning. So cleaning is quite important. Right. So what we're looking for when we're looking for cleaning. So we're looking for missing variables, right? We're looking for inconsistent coding. So if your code, if you're doing age, right, and you see a code for, you know, a code that doesn't make sense within the confines of your age category. If you're interviewing adults and you see like 1, then that's probably an error of some kind. So that would be inconsistent coding. That's one of the things you were looking for. And then the second thing you're looking for is outliers. So if a variable is very, very high or very, very low, and it doesn't really make sense within the confines of your expectations, then you need to look at that and make sure that that's correct. Now, sometimes we have codes that are, we have cases that have some outliers in them, and outliers are not intrinsically a problem. It just means we need to make sure that those outliers represent real data and not, fake data. So when you're analyzing your data and you're looking to how to clean it, often we use the descriptives or the frequencies function to inspect the data, and we're going to look at that a little bit later. Okay, so we're going to get to that stage. So when you have a large data set, it's often best to use those to try and understand what's going on with your data, because it can be difficult to check all the rows manually. Okay, but we're going to get to that in a little bit. Okay, are there any other questions before we move on?
There's a question from Amos, and
Okay.
they're asking how when you clean the Excel sheets, how you import them from Google Forms.
Right, okay, so there are Google Excel documents, right? And then those can simply be downloaded as Excel data. Now, Google Forms has like a questionnaire function, basically. So people can go, or a form function, where people can go in and they can manually enter data into your form, and then Google will provide you with kind of a data set that you can download, usually in Excel formats. And then you can import that into SPSS. So Google Forms are really, really helpful in that regard, although just please be aware that your data is not very secure on Google Forms. So that's just something you want to bear in mind when using Google Forms. Okay. Are there any other questions before we move on?
There are
Um,
no new questions in the chat box.
Hi,
Okay.
Stephen. Thanks
Oh,
for
hi.
that. I think we are done with the question, but to re-emphasize the issue raised by Israel and Fahid around confirm whether you are using two different screens because everyone is seeing the presentation in your detailed responses. Are you elaborating on another screen so that they can also see that live?
Oh, yes. So when I did this last year, I gave this presentation. And last year we used a data set to present to our audience. And many people, A, had not downloaded the data set, so they got lost quite quickly, and B, they found it a little challenging to follow the data set that was being used because it was such a large group of people. So, as I said in the beginning, usually when you have these courses on the use of statistical software, you have small numbers, 10, 15 people in a room, and you can really go around and you can check on everyone and you can look at what's going on in their screen and you can make sure that they're following along with you and they can help them analyze the data. So now that we have a much larger group of people, it's not really possible to do that. So we're going to use a more traditional lecture formats. Now, I have put up on the screen pictures. Those pictures include data. That data is just for explanatory purposes. The content of that data is not important for what we're doing here today. This is just data showing you what it would look like in a very practical sense in SPSS. Because if we just had bullet points with no practical data, it would be very hard to visualize what this would look like in a practical sense. So, very important to remember, while these pictures that appear on your screen show data, that data is for demonstration purposes only. Do not actually worry what the data is presenting because we're not working with a shared data set. We're just working with examples to show you what things look like in practice. Because again, last time a data set was provided to everyone, people didn't download the data set. We tried to use the data set for everyone. They got lost quite quickly. Okay, so we're just using a traditional lecture format. I'm not trying to trick you by using data in the background and hiding things from you. This is just examples of data to help you understand what's going on.
Great, thanks. I think colleagues are clear now. You can proceed. Thanks.
Perfect. Okay. All right. So now, when we have SPSS, there is a data entry function, and we talked a lot about that data entry function in the first hour of this presentation. But bear in mind, that's not the main thing you're going to be doing with SPSS, right? We don't normally enter data directly into SPSS as researchers. we have existing data sets, and then we use those data sets to analyze data. It's called secondary data analysis. Okay. So bear in mind that it's important to understand how data is entered in to SPSS and the types of variables that people use. But the primary task of SPSS is really to analyze data that already exists. Okay. So when analyzing data that already exists, your big friend here is going to be descriptive statistics, right? Descriptive statistics summarize your data. Okay. Now, primarily, we want to use descriptive statistics for numeric data, right? Descriptive statistics are not a good usage for string data. Again, SPSS is not really designed to analyze string data. It's designed to analyze numeric data. All right. So if we have our data set, we've cleaned it, it's all coded nicely, all the variables are entered in correctly, we can do the main thing we want to do with SPSS, which is analyze our data. Right, so you want to go to the Analyze tab. You want to click on that tab. You want to scroll down, and you're going to see descriptive statistics. Descriptive statistics are very, very nice. And there are two main types of descriptive statistics that you're going to be using, which is frequencies and descriptives. Right. So descriptives are a key analytical tool because they help you summarize your data, right? And this is very important before we move on to more advanced forms of data analysis. Okay, so if we click on descriptive statistics, a whole bunch of things will happen. But actually, what I want to talk about first is frequencies, because frequencies are much more simple and easier to wrap our head around than descriptive statistics. So we're going to start with frequencies. So very important, you just click on the frequencies tab there, and this little window will appear. You'll see it right here as I move my mouse. You can clearly see the frequencies box. Now there will be statistics there, and there will be chart, there's format, there's style, there's bootstrap. So for most of your analysis, you're not going to worry about all this. The main thing you're going to worry about here is charts, right? You want to add charts to your analysis. Usually bar charts are quite nice. You can also add pie charts. Those are quite good. We're going to look at what that looks like in a second, right? So before we run frequencies, we need to choose variables. So we see here there's a long list of different variables. Again, it doesn't matter what these variables are for our demonstration purposes. The main thing to know is you want to choose the variables you want to analyze in your frequency. So for example, gender or age or whatever the variable is that's most meaningful to you. So you enter in your variables there. You can click chart to add a bar chart or pie chart, and then you would click OK. So let's look at what that would look like. Okay, so we're going to get some statistics here, right? Usually this is just your N. So your N is your number of cases. All right, okay. That's all N is. It's just the number of cases you have. Then we're going to get our breakdown by the variables you've chose. So here we have just a very simple breakdown by gender. Now in this data set, people identified as male and female. They didn't identify as another category of person. You can see them there, male, female, and then of course your total. Right. Okay. Here we have the percentage. who identified as male and female. So the percentage, of course, is the share out of 100, right? Now, valid percentage excludes missing data. So remember I talked a little bit before that sometimes you're going to have missing data. So people basically refused or skipped a question and therefore that data is missing. So in this example, we have 4 people who are missing, which means that our percentage, which includes missing data, you can see it right there, is going to be different from our valid percentage, which excludes missing data. So when you present data, you often want to exclude the missing variables because those people didn't respond to the question. And then this is cumulative percentage. So cumulative percentage is simply the share of how the data kind of stacks up. So it's not super useful for this example here, but it can be quite useful if you have ordinal data. So if you think how this would look if your data went from highest to lowest, most satisfied to least satisfied, cumulative percentage kind of shows you the change in level of satisfaction or trust or whatever you're doing there. It's a nice thing to have, but I wouldn't worry about it so much. Now, based on our frequency, we produced here a bar chart. Now, a bar chart is very simple. It's often the simplest way to present data, right? So it just shows you the frequency of your 2 categories, right, by the number of cases you have. Okay, and so especially if you're cleaning data, this is really useful because it will be quite easy to spot if there are inconsistencies or problems with your categorical data. Okay, so again, you can't really use this function to analyze to analyze open-ended text responses or string variables. It's not really useful for this. Okay. So I just want to talk a little bit about the explore function. So the explore function is another great tool for looking at the descriptive nature of your data set. It particularly looks at distribution spread and the central tendency of your data set. So really this is where you get a lot of your mean, median, standard error. So I'm going to go through those a little bit here. So I'm going to leave there. So this is here. This is the window that you're going to see. You're going to place your dependent variable in here. Then you're going to place your factor variable, often a categorical variable, here in this little box. And then you would press OK. And it's going to present you largely central tendency data. So let's talk a little bit about what central tendency data is, because it can be a little confusing to people what these are, especially if you're not really that used to statistics. Okay, so firstly we start with mean. So the mean is the average on a data distribution. Right? It's simply the average on a data distribution. Okay, and then there is median. So median is the middle value, right, in a list of variables that have a high and low value. So you think about something like age or something like income. What is the median value? It's the middle value, right? So how is this different from mean. So mean is the central value. It's calculated by adding up all the values and then dividing them by the number of values. So for example, if you have 150 people, you would take all their ages and then divide that number by 150. So median is really the middle value. So if you ordered the 150 people's ages by highest to lowest, what is the middle value? The value right in the center of that distribution. Now, quite important here, this often produces standard errors. So standard errors are very, very key. Whenever reporting means, you always need to report standard errors. Now, standard errors can be very confusing for people. They often find them a bit alienating. So let's talk about what they are very, very briefly. So standard errors tells you how precise your estimate of the mean is. A small standard error, a very low number, means that your mean is close to the true population mean, which means that your mean is very, very strong, right? A very high standard error tells you that there's lots of outliers in your mean, right? Which is moving your mean away from the true center, okay? So if you have a very, very high standard error, that is something that is a bit of an issue. And when reporting, people need to bear that in mind. Okay. Now, when it comes to means and medians and the rest, the more people in your data set, the more likely you are to get a small standard error, right? Because in a large data set, there are fewer outliers, right? And your estimates tend to be more stable. Okay. So very important, again, the best way to think about a standard error is it tells you how confident you can be that your mean is not being swayed too much by outliers and is reporting the true center of your distribution. Okay, right. So let's talk a little bit about what is a dependent variable. Okay, so this can be also a little confusing for people who have not worked with statistical data before, because they'll be like, what is a dependent variable? So a dependent variable is the outcome of what you're measuring in your research. It's called dependent because it depends on other factors, usually the variables that you're testing, right? So if you're, for example, studying income, you want to know how age affects income. You want to know how gender affects income. You want to know how geographic location affects income. So income is your dependent variable, and all those other ones, we talked about age, gender, geography, etc. They're your independent variables. What we call in SPSS your factor variables. Now, independent variables can be anything. They can be continuous scale variables, they can be ordinal variables, they can be nomial variables, etc. The type of analysis you do to look for factors largely depends on the type of independent variable that you have. Now here in front of you, we are running simple mean, median, standard error. That's what we're doing here. So when doing that, we need to think about what type of variable we're choosing. So it doesn't make sense to choose a nomial variable, right? Because nomial variables, there's no order, right? There's no order between the one we assigned to a specific value for our nomial variable and the two we assigned to the nomial variable, right? There's no order there. So what we want to do is we want to choose a variable in which there is an ordered numerical value. So for example, incomes grid here, 0, low, 1,000,000, very, very high, right? So the median between those two numbers will be very, very meaningful. The same with age. We can also do this with Ordinal variables, very satisfied, satisfied, neither satisfied nor dissatisfied, dissatisfied, very dissatisfied. Right, because so very important to bear in mind. Okay, then when producing these things, it's always nice to produce a histogram. Now, histograms are very, very nice. You just simply click on plots and it comes up as an option, right? You can see it there, right? You would click on plots right here. You would go down to your explore plots window. You would see histogram there. You simply click histogram. Now let's talk a little bit about what is a histogram. Right, so histograms are a visual representation of data. Usually what happens is that histograms sort out your distribution and put it into intervals, or we call bins, right? Usually this is, it's like 10 or 20 bins depending on. And it allows you to see the distribution of your data quite easily. Right? This is unlike a bar chart, which is used for categorical variables. Histograms are used for continuous variables, right? So how many people in a certain age group, how many people in a certain income group, right? Each bar is going to show you the frequency or how common that range is in your data, right? So let's look at some examples of what this looks like in practice. Okay. So this is a histogram here, right? We can see the different bins that have been placed, right? So these bins, these are just intervals. Now, when your data is normally distributed, it's going to cluster around here, the middle, right? So if we think about our data is ranging from 0 to about 7, it'll cluster around here. But this data set is not normally distributed. This is skewed. So we can see here it's skewed to the right, which means that most of the distribution is on the right hand of the graph, which means that most people have a high value here. Okay. Right. So if it was skewed to the left, that would mean that most people would be here on the graph. They would have put in a low value. All right. And if it had a bell type view, it would mean most people were in the middle. Okay. So let's get to our descriptives. Okay, so here we can see all the different descriptives that are being offered. Okay, so firstly we see here mean. We talked about this before. We see median, right? Now here we can see standard deviation. So standard deviation is a very, very useful tool when looking at data analysis. So that is it tells you how spread out the values in a data set are. It shows you how much individual scores differ from the mean or the average. If the standard deviation is small, it means that most values are close to the mean, right? So so if you look at the histogram, this kind of helps us understand what's going on here. So if they're small, they would all be here, right? They would be close to the mean, okay? But if the standard deviation was large, then the data would be far from the mean, okay? So let's use this as our example. So our mean is 4, right? Which means that it's more like 5. So it means that the data is here. And we can see that the standard deviation is small because most of the data is in fact there. If there was a big chunk of data here and a big chunk of distribution here, then our standard deviation would be much, much larger. Okay. So standard deviation is a key measure of variability. It helps you understand not just where the center is, but how consistent the data is around that center. Okay. So what else is important here on this graph? Okay, so if we look here at our descriptive statistics, we can see here the minimum, so the minimum value, this is the maximum value, right? The range is merely the number of variables between the maximum and the minimum value, right? Now I just want to talk a little bit about 95% confidence intervals. So you'll often see this come up a lot with statistics, and these can be very confusing to people who are not, they don't know a lot about statistics, okay? So it's very important to understand what these are. Right, so these are the range of values that were 95% of the population contained. So it's really a good way of trying to remove outliers from your understanding of the data, right? So 95 out of 100 intervals would contain the true value. So it gives you, so we can see at the upper bound and the lower bound. So it gives you information that's much more insightful than a simple central value, right? It tells you how precise the estimate is, right? So a narrow interval means that the estimate is precise. A wide interval means that there's more uncertainty, right? Often because your data set isn't very large, the larger the data set, the more likely responses are to cluster around a central point. And you can see here that, you know, they do cluster around a central point because we can see it right here, right? And then this is the mean of those people who are, it's called the 5% trim mean, the mean outside this 90% interval. Again, what we can see here is that it's also quite, it's consistent with our main mean, which indicates that, you know, our data set tends to cluster around a very, very single point, right? Which of course we can see there now. So this is quite important. So I'm going to take a small break and talk about questions that people have before we move on. Okay, does everyone understand? Does everyone understand the question? Oh, sorry.
I was saying there are no questions in the chat box.
Okay. Right. Okay. So, right, before we move on, I just want to talk a little bit about the Shapiro-Wilks test. So this is a statistical test used to check whether your data is normally distributed. In other words, does it follow a normal bell-shaped curve, right? So many statistical tests, right, like the t-test and the ANOVA test, which we talk about a bit later, assume your data is approximately normal, right? So before running those tests, it's usually a good idea to check the normalcy of your data. So the Shapiro-Wilks test helps with that. So how it works is that the test compares your data to a perfectly normal distribution, right? It gives you a p-value. And we talk a lot about p-values in this presentation, right? So if the p-value is below 0.5, your data is perfectly normal, right? And you can use parametric tests like the t-test. If it's above 0.5, your data is not normal, and you might need to use non-parametric tests, right? Like the Spearman test, which we will talk about a bit later. So how do we run this test? Right, so it's very, very easy. You go to analysis, you go to descriptive statistics, you look at your explore command, just like we did before. Let's bring it back so we can see clearly how this is done. Right, so you have, this is it here. You go to your explore command, you go to your plots command, and then you click your normal plots with tests, right there. And this will include the Shapiro-Wilks test. And this will give you a sense of the normalcy of your data. Okay, so that's very important. It's just that it's quite nice to check this before you do your main set of correlation analysis. You want to see if your data meets the normality distribution. Okay. Right. So moving on. So let's talk about a scatter plot. So scatter plots are very, very important, and they really help you with scale data, right? So age, income, any data which is, you usually from 0 to 100, right? Now, these are what we call continuous variables, right? Now, we're going to look at an example of a scatter plot, but just very, very briefly on what a scatter plot is. So each dot in the graph represents one person or one case. We talked about this before. The distribution of the dots shows their value on the x-axis. So the x-axis is your independent variable, and the y-axis is your dependent variable. Right. Now, scatter plots are useful because they help you see patterns in the data. So if the dots trend upwards, it suggests a positive relationship, right? One variable increases, the other tends to increase. If the dots trend downwards, that's a negative relationship. As one variable increases, the others tend to decrease. If there is no pattern, it means there's no relationship between your two variables. Scatter plots are also really good because they allow you to spot outliers in your data points that don't follow the pattern, that exist outside any specific pattern distribution that you can see. Now, in SPSS, you can create scatter plots quite easily, right? You go to the graph, right? I'm gonna do it. See there's graph. You go down to here where you see all your different types of charts, right? You select scatter or dot, right? And it comes up here, and then you want to select your scatter plot there. Okay. Now, when the scatter plot comes up, you're going to be confronted with this screen, and you want to choose your dependent variable and your independent variable. Remember in the previous slide, we talked about the difference between independent variables and dependent variables. Okay, so your independent variable, right, is the x-axis, and your dependent variable is your y-axis. Okay, and that's what it's going to look like in practice. And remember, we're looking at the relationship between two continuous variables. So an example of this would be the relationship between age and income. Does your income increase with age, or does it decrease with age? So let's look at what this would be in a very practical sense. Right, so here we have created our scatter plots. Right. And now if you choose multiple independent factors, right? If you do multiple independent variables, they're going to produce a scatter plot for each one, right? So it'll display like this. So you can see the relationship between each independent variable and your dependent variable. Okay, so you can see here some of these have a very strong relationship between the dependent variable and the independent variable, and some of them do not have a very strong relationship. So you can see there the relationship is very, very weak. So the strong relationship, again, if they're clustered tightly around a line that goes, right, you see there, clustered tightly around a line. If there's no discernible pattern, if they're kind of all over the place, they're going to look like this, right? There's no visible pattern. Okay. Now, sometimes what you can do is you can, I'll show this to you. Sorry. Back. Okay, so you can analyze your continuous variables by different categorical variables, right? So let's look at what that looks like in practice. So this is analyzed by gender, right? So you can see if certain groups will have differing responses to different variables. So for example, it might be that there's a stronger correlation between income and age for men than women. And if that's true, then we can use this to visually represent that. So you'll see that the strength of the relationship will be stronger for men than for women, and we can report on that. Sometimes there'll be no difference, and in most of these cases there really isn't a difference, and therefore you can tell that the relationship between the two variables does not differ between these two key groups. Okay. Right, so I just want to pause there to see if there are any questions about scatter plots.
The question in the chat box is asking how do you know which analysis to perform on a data set besides the initial descriptive analysis?
Okay, so your selection of, how to visually present the relationships between the data really depends on the type of dependent variable you have. So for example, if you're primarily interested in how income differs across different groups and what is driving income, then you want to use scatter plots, because scatter plots are really, really good to show continuous variables and how continuous variables are influenced by other variables. Now, scatter plots are designed very specifically, as I've said before, to test the relationship between one continuous variable, in this case income, and another continuous variable, right? So for example, age. But obviously in your data set, you're going to have lots and lots of different continuous variables, depending on what you're looking at. And this will give you a sense of how you want to present your data. So when choosing how you want to present your data, you want to think very, very carefully about what your dependent variable is. Now, when designing data tests, so here in this presentation, we're talking very much about the mechanics of how this should be done. But a very important thing to bear in mind is that all your analysis has to be based on hypotheses. Okay, so how do we create an hypothesis? So we look at the academic literature, and we look at our own assumptions of what the data should look like. And then we create an hypothesis. And then we would test that hypothesis using data. Okay. So let's look at this little box here. Okay. So this shows us that there's a relationship between two key variables. All right. Okay. It shows us there's a relationship between current salary and beginning salary. So our hypothesis could be that the salary that you start at influences the salary that you will have later in your working life, right? Because people who are hired at a high salary tend to maintain that high salary as they acquire more and more years of experience. So they will have a higher salary further on in their working career if they were hired at a good salary to begin with. So that would be our hypothesis. And then we would test that hypothesis using data. Well, let's think of another hypothesis that may assist you here. We're looking at the relationship between income and age. So as people enter their working life, they acquire experience. That experience will guarantee them a higher rate of income and advancements in their job, and therefore the older you are, the more experience you have, the higher your income. We can even create a hypothesis tailored to differences within that initial hypothesis. So, for example, you could say that when women enter the working world, they have to take time off to look after children and to bring up children, which means that there will not be a strong correlation between age and income because of this break. Men do have to take time off, so don't have to take time off to look after children. As a result, there will be this break between, there won't be this break. Therefore, their income will continue to grow at a more steady pace with their age. So we'll see a more stronger relationship between age and income for men and a weaker relationship for age and income for women. So the long and short of that is it's all really based on your hypothesis, and then you think, how best do I test that hypothesis with data? Okay, are there any other questions?
No, there are no questions in the chat box.
Okay, excellent. Right. So now let's talk about a t-test. So a t-test is very, very standard type of test that is used to test the difference between the means of two groups, right? Often when we talk about a t-test, we're talking about a very specific type of t-test, which is an independent samples t-test, right? Or a paired sample. I mean, there are other types of t-tests really depending on your data and the data analysis you want to use. So there is a paired sample t-test and a one sample t-test, but normally we're not so interested in those types of t-tests, right? So when choosing your t-test, remember what I said before about your dependent variable. So your dependent variable really should be continuous. It should be a it should have an ordered nature, right? It should go from highest to lowest, right? Okay, because what you're interested in is means, and means really work best when you have high to low data. All right. So if we keep in mind with the example I discussed before, right? We talked about, do men and women differ in average income? Right? Your t-test is a really good way of trying to understand whether that's true, right? Because it compares the means between two independent groups, right? And so what we're looking for is to see if the difference between these two independent groups is statistically significant. So when we say something is statistically significant, what we're saying there, it is unlikely to have happened by chance, right? So before we go on, I just want to mention very, very briefly about, what a paired sample t-test is and what a one sample t-test is, just in case there's going to be any confusion on those two very important types of t-tests, which you don't normally use, but it's quite important to actually know what they are. So a paired sample t-test compares the same group at 2 points in time. So this is quite useful when you have panel data, right? So you interview someone at point A, and then you go back a few months, a few years later, and you interview them at point B, all right? Or, for example, if you have training or an intervention of some kind, so you interview people before the intervention or the training or what have you, and then you interview them after the intervention or the training. It really allows you to understand if the differences between those two time points were statistically significant. Right. So, and then your one sample t-test compares the group's mean to a known value, right? So, for example, this is used a lot in when you do tests with different samples of people. And so your known value would be the pass rate, which is say 50 if your test is out of 100. And then you can compare the mean to the known value, and that will show you something quite important. But normally we don't use those two. We normally use your very standard independent sample t-test. Right, so your independent sample t-test is going to produce p-values. So p-values, right, very, very important. If the p-value is below 0.05, the difference is considered statistically significant. But if it's above 0.05, the difference might be due to random variation. Right. So let's talk a little bit about what is a p-value, because it's going to keep coming up again and again and again. Right. So your p-value is the number that helps you decide whether the results of a statistical test are statistically significant, right? Whether they are due primarily to chance or not. Now, what the p-value tells us is the probability of getting our results if the null hypothesis was true, right? So what is the null hypothesis? Is that there's no real difference or no real effect. That's what the term null hypothesis actually means, right? Now we use as a rule of thumb 0.5, right? That it just means that there's a 5% chance that the null hypothesis is true, and 5% is considered, the gold standard in statistics. Now, obviously, you can have a smaller p-value, say 0.02, which means there's a 2% chance that the null hypothesis is true, right? So the smaller the p-value, the better it is. The larger the p-value, the worse it is. Now again, this 95% that we go for, that's just your standard. That's what's used a lot in statistics. It's considered, again, a good yardstick to decide whether something is true or not. But again, it's not the point at which water boils. It's not a very binary variable. We, as people who work with stats, have just decided on this number. It's a little arbitrary, but it does represent something. So just please bear that in mind when you see it, because it's going to come up quite a bit. Okay, so we're just going to move on now. Right, here we go. So we're going to set up our t-test. Okay, so t-test.
Hi, Stephen.
Oh, yes?
Sorry to interrupt.
Please go ahead.
We have been going for 1 hour, 30 minutes. Just wanted to find out, when do you intend to take a break for colleagues to get some time to stretch and stuff?
Oh, of course, yes. It might be a good idea to take a break now, because, we want to set up the t-test and we're going to look at the results, and that takes a little while. So maybe we should take a break now for about half an hour. Because I know that that's what you wanted to give everyone. Now, are there any questions that we would like to take before we take this break
Yeah.
on some of the
Before we
things we've been
take
talking about?
before we take the questions, Steven,
Sure.
how are we doing for time in terms of your slides and how you have scheduled the
Oh,
presentation
no, we're
today?
doing fine for slides.
Okay.
Sorry, for slides. Why am I saying slides? That's a bit silly. We're doing fine for time. We're good with
We're
time.
doing time for time. Okay.
Yeah.
Lesego, do we have questions, colleagues from the floor? Do you have questions you'd like to pose to Steven before we go on a break?
There are no questions in the chat box at the moment.
Okay. Well, yes. Well, then let's take about half an hour, and then we can come
Okay.
back, and then we can go through. We can go through the rest.
Okay. So we're going to reconvene here at 11:15.
Perfect. I will see everyone then.
Thanks, colleagues. We are officially on a break. Time to stretch and refresh. It's 11:15 after 11. We'll start with the next part of the session. I'll hand over to Dr. Gordon to continue where he left off. Just a quick question, Stephen. We have in the chat around the structure. The structure of the training, if you are going to share with the software so that they can follow sort of a demonstration of the SPSS software.
Right. So yes.
Perfect.
So this is something we talked a little bit about at the beginning of the session, but I'll tell you what happened last year when we did this presentation is we used a practical demonstration of the software for participants and went through things kind of step by step. And because people had not downloaded the data set and had not the right SPSS version that we were using, there was a lot of feedback about people feeling a bit lost. So a decision was made to utilize a more traditional lecture format for this training academy session. But I mean, if this is not, we could always change the next time we did this lecture for future, so that we could go back to a more practical utilization. But again, just bear in mind, the both approaches have kind of downsides that people have sort of emphasized, so that if you went with something in which people are required to have the data sets and then we go through the data set sort of step by step, then people also complain about feeling a bit lost. So this, I mean, there are pros and cons to both sides. Yeah. So that's
Okay,
kind of the
thanks.
way things all kind of shaked out in terms
Yeah,
of this specific
I-
training academy. Normally, when we do these types of lectures, sort of how practically use the software, it's often best to do it with a very small group of people, so you can kind of check that everyone's in the same place as we go through these things. With these large lecture formats in which there's a large group being lectured to, a more traditional format is often best. But I mean, can be re-examined as we think about how to improve things going forward.
Yeah, thanks for that, Stephen. And I think it's an important point you are raising. Colleagues will be at the end of the session. Lesego will share an assessment link in the chat, and we request all participants to complete the assessment in detail. And that's what we use to plan for the coming years. Structure and inclusion of things that they think might be useful for them. So it will be an important point to raise when Lesego shares the link in the chat. But thanks, Stephen.
Yeah, whatever we can do to improve the experience for, the students, because we want people to really understand what's being done and how best they can improve their own academic skills for their research. So please, if you have those type of comments, please make them. And when we reconsider this for the future, we'll definitely factor that in, because we always want to make these things better. You respond to feedback as it comes up to try and improve things for the next year. Okay, so I know we just had a break and we were able to revive ourselves somewhat. I just want to see if there is any questions before we begin talking about t-tests. So we talked about that in the previous part of this presentation. So a t-test is simply a statistical test used to compare the means of two groups to see if the difference between them is statistically significant. That is, it's unlikely to have happened by chance. Now, before we talk about how to set up a t-test in SPSS, are there any questions about that basic idea?
There are no questions in the chat
Okay.
box. You may proceed.
All right. Perfect. Okay. So now we're going to talk about how to set up a t-test in SPSS. So this is one of the most basic tests that you'll do. Now, in order to do this, what you need to do is you need to go to Analyze, right? You go down to Compare Means. You're going to click on Independent Sample t-test. Analyze, Compare Means, Independent Sample t-tests. So in the dialog box that appears, which you can see, hold on a second, I'm going to get that red thing there. So as you can see, this is it here, right? You're going to move your dependent variable into the box labeled test variables. Remember, we talked a little bit about what dependent variables are, right? So again, this needs to be a continuous variable, right? Something like age or income. And then you can move your independent variable, right, into the box here. Now, so this is the group variable box. Now, before we run our test, we need to define our groups. We need to enter the values that represent the groups in your data. So if we're doing gender, for example, we can have gender coded as 1 for male and 2 for female. Therefore, 1, 2. Okay. So once we've done those things, we can run our t-test. Okay, so let's just go through that one more time. All right, so firstly, you want to go to Analyze, Compare Means, Independent Sample t-test. Right, then you're going to get this box. You want to move your dependent variable into the test variable labels box, right? Usually this is something like income or age, any kind of continuous variable. Then we're going to have your independent variable. We're going to move that, right, into your group variable box. And we're going to define the group, right, entering in 2 values that represent the groups in your data. So for example, when we use the issue of male and female, here we go, we get group 1 and group 2, male, female. Right. Okay, make sure your variables are correctly labeled in the variable view, right? You should have 1 numeric variable and 1 categorical variable. Here we have age and we have income. Okay. So let's look at what this produces. So you're going to get two primary tables, right? You're going to get group statistics. This shows the mean, the standard deviation, and the number of cases in each group, right? And that it's a little bit like the descriptive statistics we talked about before. And then you get your independent sample t-test. This is where you have the t-value, degrees of freedom, and then your significance tests, right? Specifically your two-tail test, right? And then your p-value. Yeah. Now, when looking at this, you're going to notice the Levin's test for equality of variance, right? So this is quite an important test, okay? Now, this will show you here, you'll see significance. So the significance is below 0.5. You need to assume equal variance, okay? Now, so I want to talk a little bit about what this is, because some people can be a little confused about this. Right? So this test how do I put this? It's used to check a very important assumption about the independent sample t-test, right? That the variance of the two groups are equal. In simple terms, if the test spread or variability of scores is about the same in both groups, right? This matters because the regular t-test assumes equal variance. If the variances are very different, the standard t-test might not be reliable. All right. So if our variable is greater than 0.05, this means that the test is not significant, which means that the variances are equal, right? And you can really see this right here, right where I'm pointing here, right? If it is below 0.05, then this means the test is significant, which means that the variances are not equal. Okay. Right. So if it is not significant, we want to use the top row, which is right here. And if it is significant, we want to use the bottom row, which is right there. Right? You want to look at the top row of the t-test if the Levin's test for equality of variance is not significant, and the bottom row right there if it is significant. Okay, so the significance two-tail value tells you whether the difference is statistically significant, right? That's quite important. Okay, if the p-value is less than 0.5, the difference between the groups is statistically significant, right? Which is good. Okay. Now, SPSS provides a 95% confidence interval for the difference in means. If the interval does not include 0, then the difference is significant, right? And the width of the interval shows how precise the estimate is. Remember, we talked about what a 95% confidence interval was previously. Okay, so t-tests are very, very important because they really show us whether the difference in mean between two groups is statistically significant, right? And therefore is a meaningful or worthwhile finding. So I'm just going to pause here to see if we have any questions. To see if we want to talk about interpreting the t-test before we move forward.
There are no new questions in the chat box.
Okay. Excellent. Right. Okay, so let's go on. So here I want to talk about the Pearson correlation. So the Pearson correlation is a very important correlation that is very standard in advanced statistics. Right. So basically it's used to measure the strength and direction of a linear relationship between two continuous variables, right? It's going to give you the number called a correlation coefficient. Usually you're going to write this up in your data set as R. Okay, so this coefficient ranges from 0, right, -1 to +1. So an R value close to +1 means a strong positive correlation. As one variable increases, the other one also increases. And there's an R value which is close to -1, which means a strong negative relationship. So as one variable increases, the other one decreases. Right? The R value near 0 means no linear relationship between the two variables. Right? So we can look, for example, at the relationship between, so say you're studying for a test, you can look at the relationship between the number of hours you studied for and exam scores. So a positive correlation between number of hours studied and exam scores would indicate that the more time you spend studying, the higher your exam score. Right? A negative correlation between would mean that the more time you studied, the lower your exam scores. Perhaps due to the fact that, too much studying creates stress and sleepless nights, which means that you're not going to do very well on your exam. But again, this really depends on your hypothesis that you establish. Now, your Pearson correlation is also going to provide you with a p-value, which is going to tell you whether the relationship is statistically significant. Remember that your p-value below 0.5 means that the relationship is significant, meaning that it's unlikely due to chance. Remember, we use the 0.5, 95% confidence indicating that we're 95% sure that the null hypothesis is not true. Okay. Now, the Pearson correlation only detects linear relationships, right? You're not going to pick up nonlinear or curved patterns in your analysis. Okay. So let's talk about how we do a Pearson correlation in SPSS. Right. So you want to go to analyze, right? You want to go down to correlate, and then you want to go to bivariate. And you click bivariate. You can see it there. Analyze, correlates, bivariate. Okay. Then you're going to go to your bivariate window, and you want to select two continuous variables, right? At least two continuous variables. Okay. Now you want to make sure that the Pearson little box is ticked there. Okay. You want to leave the two-tail selected unless you have a very specific reason to leave it unselected. Now, you can click options and flag significant correlations to highlight statistically significant results, but that's not really that necessary. And then you would press OK. Right, so again, you go to analyze, you go down to correlate, you go to bivariate, right? You want to select, again, continuous variables. You can tell they're continuous because they have this little ruler type variable next to them. And then you want to ensure that you've clicked the Pearson correlation there and make sure that the two-tailed significance is selected unless you have a very specific reason for it not to be selected. Okay, so now we're going to talk about interpreting our Pearson correlation in SPSS. So now we have a table showing the Pearson correlation with your p-value, right? Remember, let's go over this again. The R value tells you the strength and direction of the relationship, right? So if it's +1, right? If it's positive, right, above 0, then it tells you it's a strong relationship. So usually something between 1 and 0.5 is considered a very, very good relationship, right? If it's between 0.5 and 0.3, this is much more moderate relationship. If it's between 0.3 and 0, then it's a weak or not really a positive relationship. And then you can think, for example, negative values follow the same format. It's just now it would be negative. Negative -1 to negative -5, negative minus 0.5 to negative minus 0.3, etc., etc. Right. Okay. So the p-value tells you whether the relationship is significant or not. Right? So below 0.5, your relationship would be significant. Above 0.5, not considered significant. Okay. Right. So in summary, when using your Pearson correlation, right, you want to use it to compare two continuous variables, right? You want to look at the R to see how strong the relationship is, and you want to check the p-value to make sure that the relationship is linear. Now, when interpreting your data, you want to make sure that you're interpreting it in the right way. So causation does not imply, correlation does not imply causation, right? Just because two variables are correlated doesn't mean that one variable causes the other, right? So let's talk about what this is in practical terms, okay? So you have two variables, and that you find there's a strong correlation between these two variables. Right? Two things happening together does not mean that one causes the other, right? So if we see an increase in study time, we can hypothesize that this causes higher test scores, right? We expect to see a correlation between the two. We can make a judgment that study time increases high test scores, right? If we see a correlation between smoking and lung damage, we can make an assumption that smoking causes lung damage, right? But then there are many cases where causation does not cause correlation, right? So think about the following example when trying to understand this point, right? So there might be a third variable that affects the relationship between two continuous variables. Think about the example of high test scores and number of hours studied. If we find that studying is correlated negatively with high test scores, meaning that the more you study, the lower test scores you are, it's probably what's happening is there's a third variable which is influencing attitudes. For example, it's really the lack of sleep that's causing low test scores, not the number of hours that's causing low test scores, right? So there's a classic example they always use with causation and correlation, which is that, there's a correlation between ice cream sales and drowning rates. This does not mean that eating ice cream causes drowning. What this means is that during periods where there's hot weather, people go out and they buy ice cream and they eat it, but they also go swimming more when the weather is warm, which means again that there's a third variable, which is the hot weather, which is leading to the issue that we're seeing here. Right. Okay. One more very important thing, especially with you working with very small data sets, is that your Pearson correlation is going to be affected by outliers. So if there's a few cases which have a high number of, which have, very big outliers, it's going to really mess with your Pearson correlation test. So if you're working with small data sets, this is going to be a bit of a bigger problem. So you really want to think about this and try and do something about it when conducting your test with the Pearson correlation. Okay, so I want to move on to talk about the Spearman correlation, but before I do, are there any questions?
Yes, Dr. Gordon, there's a question from Aneli.
Okay.
They're asking what type of test will be used to analyze the correlation between an independent variable moderating another independent variable and dependent variable.
Yes. So we're going to talk about this a little bit later. So these tests, these are very simple inference testing. So we're just looking at very, very simple data. So now at the end of this, we're going to look at ANOVA testing. And specifically, we're going to talk about 3 different types of ANOVA testing. We talk about one-way ANOVA testing, two-way ANOVA testing, and covariates. Well, basically ANOVA testing with covariates, which is going to allow you to control for maybe a third variable, which is causing or maybe causing the relationship between your 2 variables to differ. Now, at the more advanced level, what you want to do is you want to do a multivariate regression analysis. Now, multivariate regression analysis is a very powerful tool that you're going to be using in a lot of your more advanced analysis. It's not really for a beginner's course in SPSS, but it's very, very useful to think about what you need to be working towards when using SPSS. So if there is time at the end of this lecture, I will go through what a multivariate regression is in terms of SPSS, maybe tell you a little bit more about that. Okay. Okay, are there any other questions?
No, there are no new questions in the chat box.
Okay. Right. So let's talk about a Pearson correlation test. So a Pearson correlation test is a statistical test that measures the strength and direction of the relationship between 2 variables, just like our Pearson correlation, but it's used when your data doesn't meet certain assumptions. So here it's very specifically used when your data is not normally distributed, right? Which means that the relationship between your variables is not likely to be linear. So primarily it's used for variables that are ordinal, meaning variables that are ranked. So we talked about satisfaction scales, education levels, for example, occupational rankings is another good example there. Right. So instead of the actual variables, what your Spearman does is it converts the data into ranks and then calculates the correlation between those ranks, right? Now, just like your Pearson test, it's going to produce something which is, scale between -1 and +1, right? Where +1 means a perfect positive relationship. What? One rank increases the other rank also increases. And the -1 is a perfect negative relationship. As one rank increases, the other rank decreases. So when you have 0, right, it means that there's no relationship. Now imagine you're looking at the correlation between a person's income and their job satisfaction. So even if income and satisfaction don't follow a straight line pattern, Spearman can still measure how closely they rank together. So let's summarize, right? You want to use your Spearman correlation when your variables are ordinal, right? When the assumption of normalcy is violated, right? Remember we talked about the Shapiro-Wilks test earlier, right? And when this, and otherwise, what you can see is if you did say a scatter plot, when we talked about scatter plot earlier, you're going to see a curved or monotonic relationship. So a monotonic relationship means that as one variable increases, the other variable tends to either only increase, only decrease, but not necessarily at the constant rates. Okay, so the Spearman correlation it's flexible, it's non-parametric, alternative to your Pearson correlation, right? Okay, so how do we run this in SPSS? Okay, so very, very straightforward. So you open up Analyze, right? You go down to Correlates. You go to Bivariates. I mean, it'd be easier if I show you. Hold on a second. All right, okay. Right, so you go to Analyze. You go to Covariates. You go to Bivariates. You're going to get up this little box here, right? And therefore, instead of ticking Pearson here, you want to tick Spearman. Okay. You also want to leave this two tails selected unless you have a special reason not to. And it's always helpful, you can flag significant correlations by clicking the flag option there. Okay. Right. Now, let's talk about what type of data the Spearman correlation is going to produce. So it's going to produce something called the rho, R-H-O value. Now this value is the correlation coefficient, all right? Very, very important. Now this is what we're talking about here in terms of something being close to 1 or far away from 1, all right? So if it's +1, you got a strong positive relationship. If it's -1, you have a negative relationship, which is strong, right? If it's between +1 and 0, it's a more weaker positive relationship. If it's between -1 and 0, it's a weaker negative relationship. If it's close to 0, it means you have a very weak or no relationship. Now, your p-value is going to tell you if the relationship is statistically significant, right? So your p-value is going to tell you if the relationship is either mostly due to chance or not due to chance. So if it's below 0.5, means the relationship is significant, and if it's above 0.5, it means that there's not enough evidence to claim that this is a real relationship. Again, we're using 0.5 as your yardstick, right? To really make this judgment. Okay. So to recap, you want to use your Spearman correlation when working with ordinal data on non-normal distributions, right? You want to look at your rho coefficients, right? The rank ordered correlation to see the strength and direction of the relationship. And you want to check the p-value to see if the result is meaningful. So all this stuff is right there. Okay. Right. So that's the Spearman correlation. Okay. Right. So should we talk about anything else before we move off the Spearman correlation? Okay, right. Moving on. So let's talk about chi-squared tests. So your chi-squared test is used to examine the relationship between two categorical variables, right? So technically what you want to do is it's a chi-squared test of independence, and you can look at whether, for example, electoral participation is associated with gender, right? So those are two categorical variables. Do you participate in elections and gender? And you can have ordered categorical variables or ordinal categorical variables, and you can have nomial categorical variables, right? So what the test does is it compares the actual counts, the observed frequency, in the contingency table with the expected counts. You would see if there was no relationship between the variables, right? So the basic question you're asking with this chi-squared test is, are the two variables related, or are the patterns we're seeing due to chance? Okay, so if the observed and expected outcomes are very different, the chi-squared statistic will be high, and the result will be more likely to be statistically significant. So maybe to try and help you understand this, let's talk about like a practical example, right? So imagine you surveyed people on whether they preferred to drink tea or they drink coffee, right? And you broke your results down by gender. A chi-squared test will tell you if men and women prefer different drinks, or if the difference between whether they prefer coffee or tea is just random. All right, so what you're going to be looking for, again, is your p-value. And if your p-value is less than 0.5, we say that the relationship is statistically significant, right? So the variables are likely to be associated, right? If it is greater than 0.5, then we say the relationship is not statistically significant, right? The variables are likely independent, right? Now, this really works best when you have a large data set, right? If you have a small data set, you're going to have a lot of problems running this test. It's really not good for small data sets. You really want to have a large data set. Okay, so how practically do we run this in SPSS? Right, so let's talk about this practically. Right, so you're going to go to Analyze. You're going to go to descriptive statistics. You're going to go to crosstabs, right? And then so you're going to go here, Analyze, descriptive statistics, crosstabs. You're going to get this little box here with your crosstabs box, and then you're going to move your categories into rows and then columns, okay? So what you want to do when selecting your variables, you want to make sure that your variables are categorical, right? So categorical, it has this little symbol. So these three circles, one red, one blue, one green. That's how you know that the variables are categorical, right? It doesn't matter which row and columns you place them in, but please just be consistent when running the tests. Okay. So here what we're doing is we're testing whether the null hypothesis is true or not, right? So the null hypothesis is that the two variables are independent, right? There's no association between them. And the alternative hypothesis, our rejection of the null hypothesis, is the two variables are dependent. There is, in fact, an association. All right. So when you get here to our crosstab, you put in rows, you put in columns, then you go to statistics. You come down here to our statistics box. And then what you want to do is you want to click chi-squared. Now, normally, chi-squared are run for ordinal variables, right? So satisfaction level, and then you would have another, sometimes nominal, sometimes ordinal variable, and you could compare the two. Now, when doing your chi-squared test, however, you do also want to look at nomial relationship between two nomial variables and relationships between two ordinal variables. So I'm gonna talk about the different types of tests you can do for those in a minute. And we'll go through, there's quite a few of them. So we'll go through some of them, but it's not really important when you're doing just a very standard basic test, right? So normally we don't have all this sort of additional testing. You just want to do the chi-squared. So let's look at what that is first, and then we'll look at the others. Okay. So first we show, when you just do your normal basic chi-squared test, what you're going to see is you're going to see a few tables. So firstly, there's going to be your crosstab table, right? Then there's going to be your summary table, and then there's going to be finally the chi-squared test. Okay. So this is what's going to happen when you see your different tests. Okay. So what are each of these tables showing us? So the first table, your case processing summary, is just showing you the observed count, the actual data for each combination of the variables that you've selected, right? So it's the actual number of cases in each category and what we would expect if there was no relationship between the variables, right? You can use this to spot where the biggest differences are between the categories, right? Now let's look at the chi-squared test table, which is the main thing you want to look at. So you want to look at the row called Pearson chi-squared test. So it's this row here. And you want to find it's a little hard to say, it's the asymptotic significance two-sided column, right? And that's your p-value. Remember we said if the p-value is below 0.5, it's statistically significant. There's a real relationship between the two variables. If it's above 0.5, then there's a good chance that this is due primarily to being random, right? So then we have our degrees of freedom, right? And we have our value. So it's those two that you want to report on when doing your, when you report on this in your report, right? It's those, you want to mention those two. And it's gonna be your x squared. That's what that's called right there. Okay, so now I just want to go back. We're going to talk a little bit about some of these tests. Right, so what is the Pi and Kramer V? Right. So, okay, so the Pi and Kramer V. So when you run a chi-squared test in SPSS, right, then you're going to get a result that is statistically significant, right? This is where the Pi and Kramer V come in. These are the measures of the strength of that association, right? Now, when you want to use this test, right? Under very specific conditions, not under all conditions, very specific conditions. Okay. So you want to use it when you want to see the relationship between two variables that are dichotomous. That is when they have, 0, 1. Usually yes, no questions are quite good. Right, okay. Then your p coefficients, so with your pi coefficient, sorry, it's going to range from 0 to 1, right? So the closer to 1, the stronger the relationship. Okay. Now your Kramer V, right? The Kramer V is when you have one variable that has more than two categories, right? That's where you run this one. Okay. Now very much like the other one, 0, weak correlation, weak association, 1, strong correlation, and then between that, you're going to look for the strength of the relationship. So between 0 to 0.1, it's usually very weak or there's no relationship. Between 0.1 and 0.3, it's a weak but still reportable relationship. Between 0.3 and 0.5, it's moderate. And then anything above 5 is considered quite strong. Okay, so that's quite, well, I hope that's quite straightforward. We'll take questions in a moment. Okay, now let's talk about the lambda test, which is this test right here. Now, this is another test which is quite good. Now, this is also used to evaluate the strength of the association between two categorical variables, focusing on how much one variable reduces the error in predicting the other, right? It's often used when both variables are nominal. Remember, this is said here. So if you're looking at the relationship between gender and, living in a specific region, for example, living in an urban versus rural area, right? That's where this test comes in, when you have nominal variables, right? So lambda is scaled much like pi and Kramer's V. So 0, right, means that knowing one variable does not improve your prediction, meaning that there's no association. And then lambda 1 means that knowing your variable helps you predict the other much better. Otherwise, to say that there is a strong association. And it's scaled in much the same way that the previous one was scaled. It's quite helpful when working with nomial data, and you want to talk about predictive power. Okay, so we're just going to talk now about the gamma test for your chi-squared. All right, so the gamma test for your chi-squared. So this is when you have ordinal data. It's very commonly used for ordinal data. It's the measure of it. Again, it helps you test the strength of the association between two ordinal variables, right? So an ordinal variable would be something like education level or level of satisfaction with a certain thing. It tells you how strong the relationship is and in what direction it's going. And it uses much the same format as many of the tests we talked about previously. So +1 means a perfect association, right? Because one variable increases, the other one decreases. -1 means a negative association, as the one increases, the other decreases. 0, of course, meaning no association. Right. Okay. There are other tests, but these are quite standard tests that you want to use when doing your chi-squared test. You don't have to do it, but it is quite important if you want to talk about strength of association. So I'm just going to take a little bit of a beat here to see if we have any questions that people would like to ask. Okay. Right. Now let us go on
Doc, just before you proceed,
Oh, sure.
yeah, when you are talking about the chi-square analysis, you talked about, large data sets and small
Mm.
data sets. I'm just curious to know how much is considered large data set, how much is considered small data set.
Oh, of course, yes. So large data sets is usually about 300 cases would be considered a large data set. Now, most data sets are much larger than that because this is a type of software designed to work with large data sets. Okay. But there are, of course, smaller. So sometimes when you're doing medical research, you have quite a small data set. It's like 50 cases, for example. That means that the data set is a bit small, and therefore the types of tests you're using have to be a bit different because you need to be able to control for the types of variants that would come up with a large data set. Because at the very basic level, you need enough observations to make certain data sets more accurate. I mean, certain chi-squared tests more accurate than others.
So in essence, you're saying that the data set then determines the type of test you are going to carry on that particular data.
Absolutely. So it really, like, again, this software is designed for large data sets. So the chi-squared test works, it works better with larger numbers. So the types of data you work with, usually it's a few thousand observations. A few hundred are considered still pretty good. You can still work with it. If you have less than 100 cases, it's much better to use other types of tests. So let's think about what tests would be better for a small data set. Okay.
Okay, we are good, Doc.
All right, so let's just think about what types of tests would be accurate for a smaller data set. So the Fisher's exact test is quite good, right? So the Fisher exact test is something you really want to use for a small data set. I'll show you where it is. Okay. It should be. So you go to, so if you go to so where's this here? Okay, crosstabs. You go to crosstabs, you go to statistics, and then you will be able to select your Fisher's data set, right? Fisher's exact test, right? And that's quite good for small data set. Okay. So that's something you just want to bear in mind when doing that. There's also an exact bimodal test, right? That's for nominal data. And then is the Wilks-Coggins signed rank test. A little hard to say. It's when you have two related groups and your data is not normally distributed. And that also is quite good for small data sets. Those ones were designed very much for kind of medical research. So you have medical trial research and you only have like 20 to 30, 40, 50 people. And that's quite good for people like that. Okay. Right, so now I just want to talk about a
Sorry
one-way.
to
Oh,
interject.
please.
Dr. Gordon, there's a question from Cyril in the chat
Okay.
box, and they're asking if they mistakenly enter a different type of variable, not categorical, does the system return an error message to show that they haven't entered the categorical variable?
Oh, no, unfortunately not. You're just going to get, basically your data will look bad. So it will look strange and unworkable. And this will basically tell you that, look, my data is not working. So the system doesn't know that you've entered in the wrong variable, right? The system is not aware of that. So you need to make sure you're entering in the right variable. So what's quite what I like to do when thinking about running all my tests is what you do is you take a piece of paper, you sit down with your piece of paper, and then you plan all your different tests as you go down so that you know exactly what you're running and then why you're running it. And then you would go to SPSS and you would enter these things in. Because what's going to happen if you try and do it in another way is you're going to go through this process where you're going to get very strange results, and then you're not sure why you got those results, and then you have to work out why you got them, and you might spend quite a lot of time before you realize that you just entered in things incorrectly. Because the great game with survey research is to find out why you're seeing the correlations that you're seeing. So if you expect to see a correlation in your data between, say, the number of hours you studied and exam results, and you don't see a correlation, that's an amazing finding, which suggests something fundamental is going wrong with your expected result, which is that the more you study, the less you're going to see. Okay, so what you want to do is you want to plan carefully everything so that you don't make those type of errors. Yeah, exactly. Okay. All right. Are there any other questions?
Thank you for the clarification, Doc. There are no other new questions in the chat box.
Okay. Right. Okay. So let's talk about one-way ANOVA testing. Right. So one-way ANOVA. So we're getting kind of close to the sort of thing you're going to be doing like a lot in your analysis when you're working with bivariate data, right? So what is this type of test? Well, this is a statistical test used to determine whether there are significant differences between the means of 3 or more independent groups based on one independent variable. It compares, right, within group variability, right? So a great way to think about this, let's talk about exam scores and different demographic groups. So it's going to compare how scores vary within each groups, maybe within gender groups or population groups or language groups or regional groups. It's going to tell you right? And then it's going to look at the between group variability, how the averages differ from each other. Right. So it's going to calculate something called a F statistic. So the F statistic comes up a lot in different statistical tests, and sometimes you need to look at it, and sometimes you don't. This is one of the cases where you really, really need to look at your F statistic. Right. And we're going to be looking at it when we look at the different results. Now, your F statistic is the ratio of variances, the variabilities that we just talked about. Now, a large F statistic suggests that the group means are not the same, right? And a small one would suggest that they are, in fact, the same. Okay, now this test is also going to produce a p-value, and this is going to help decide if the differences are statistically significant or not. Remember, p-value, as I explained before, comes up a lot. It's come up here again. It's very, very important. So one of the main things you're going to look at. So before we look at how to set this up, let's just go through this one more time. So one-way ANOVA, right? The purpose is to test if at least one group mean is different from the others. It compares 3 or more groups, right? You need to use it with dependent and independent variables, just like all the other ones, right? So it's used very primarily to look at dependent variable, right? A continuous variable, either like age or income or satisfaction level, right? And then how that's distributed across independent variables. right? So here we can use our example of, test scores. So test scores would be a dependent variable. It's a continuous variable. Test scores go from, 0 to whatever number, depending on how the test is scaled. And then, of course, we have our groups, and there can be any types of groups. We can have gender, we can have language group, we can have regional groups, we can have school types, etc. Okay. Now let's look at how to set this up in SPSS. Right. Okay. So it's very, very straightforward, right? In terms to set this up in SPSS. So one of the first things we do is we go to analyze, we go down to compare means, right? And then we choose our univariate option, right? Now, in doing this, we are making certain assumptions about our data. So what are these assumptions? We're assuming independence of observations, right? We're assuming normality. So normality, the dependent variable should be normally distributed across each group. And we're assuming homogeneity of variance. So each group has similar levels of variance. So once we click on this, we can choose our one-way ANOVA, right? So we go to analysis, we go to compared means, we go to one-way ANOVA. All right, so we're going to get this little box. It looks like this. This is the box here. And then we're going to put in our dependent variable. So again, this should be a continuous variable. So exam scores, for example. And then we're going to put stuff in our factor group. Now, these are our independent variables. Now, SPSS calls certain things independent versus dependent. Sorry, they call factor lists or factor variables. That's their name for independent variables. So often when you see factor box, factor list, etc., that's what that means. It means independent variables. Okay, so we put our continuous variable. So you can see this is income. We can put test results here. We could put age. We could really put weight. We could put anything in there as long as it's a continuous variable. Then we put our factor variable in there. So again, this would be your categorical variable. Gender, for example, is a normal variable that everyone uses, but you can put anything, region, population group, etc. Okay, now there's some options here. There's some ad hoc tests, right? So common ad hoc tests includes your Tukey test, Tukey. Sorry, Tukey, the Tukey test, and the Games and Howell test, right? Those are very, very popular. So let's talk about what they are. Okay, so your Tukey test, which is the one, if you're going to use a test, this is probably the one you're going to use the most. But again, you don't really have to do this because this is not, it's not necessary, right? But what the Tukey test does is it compares all possible pair groups, means, to find which specific group differs from each other, right? So it controls for what in statistical terms we call a type 1 error rate, which is false positives across multiple comparisons, right? So you don't mistakenly find differences just by chance, right? And it'll help adjust your p-values. Right? So when you use this test is when you have equal variances between groups, right? And this assumption can be checked by the Levy's test. We talked about that a bit earlier in this session. And when you want to compare every group against every other group, right? So that's a very important test that you can run, but it's not essential to run that test, right? And that's just something extra you might want to think about. Okay, so when running your one-way ANOVA test, you want to click on options and you want to make sure that descriptive is selected. So you click on options, which is right there. You get in this little window box and it's going to have descriptives. It's going to have fixed and random effects. It's going to have homogeneity of variance testing. It's going to have other types of test. Right. So you want to make sure that descriptive is selected. Now, they are standard tests for your ANOVA, right? And one of those standard tests is going to be shown when you do these things, right? But I often find it best to use the Welsh test. So the Welsh test is a very good ANOVA test that you can use, right? And it's more reliable than the standard tests they often do. Now, this is more reliable because it does not make the assumption of homogeneity of variance, right? It does not assume equal variance amongst groups, right? Now, this is often best to use when the Levi's tests shows that group variance are unequal. Usually when your p-value for the Levi's test is below 0.05, right? Provides a more accurate result if the variance are different and group sizes are unequal, right? So it doesn't really matter what it does because you don't really need to know the sort of the behind the scenes. But if you would like to know, what it does is adjust degrees of freedom used to calculate the F statistic. And then that adjustment accounts for the variance in homogeneity and reduces the risk of false positives. Remember that type 1 error we talked about, right? So if your Welsh ANOVA produces a significant p-value, that is a p-value below 0.5, this means that at least one group means differs, right? Now, this test is not used with the Tyche test, so don't use them together, right? You only commonly use them with the Games Howell post-hoc test. That's much better where this is used. All right, but again, that's a lot of like, that for those of you who are not familiar with statistics, that might all sound a bit like gibberish. For those who know a little bit more about these stuff, that's very important. So just bear this in mind when running your ANOVA test. It's important to add this in, but you might not really need to know the deep mechanics of how it works if this is a little unfamiliar to you, but just bear that in mind. Okay, right, so let's now look at what a basic ANOVA result looks like in practice. Okay. So you're going to get a bunch of tables from your one-way ANOVA, your descriptive table, your table of homogeneity of variance, and then your ANOVA test. Okay, so how do we interpret these tests? So firstly, descriptives, very simple. You got your counts, you got your means, you got your standard variations. We've talked about this, right? Then what do we see? We see your test of variance. So the most important thing here is your p-value, your significance value. This is something I should have mentioned earlier. When we see sig, S-I-G dot, that's the p-value, right? That's what the p-value is. I should have mentioned this. I just assumed people knew this, but in case you didn't know that, that's what the p-value is. It's the sig value that's there. That would be the sig value there. So if your sig value is below 0.5, that means that the variances are equal. All right. Okay. So that's the main thing you want to check there. You're not really so worried about what those other numbers mean, right? So what we're going to do with that test of variance is we're going to see if our null hypothesis can be rejected. So the null hypothesis are the variances are equal. If the variances are below 0.5, then we assume if the variances are above 0.5, then we assume that the variances are equal, right? Proceed. But if they are below, we assume that they are unequal, and we need to use our Welsh test. Remember, we talked about the Welsh test before. Right, so let us now look at our ANOVA table. So the most important thing in our ANOVA table is our F statistic, which is this here. It says F right there, your F statistic. Right, so we really care about what our F statistic is. So if our F statistic is large, that is right, it means there are more differences than expected just by random chance, right? Which is a good thing, right? If it is small, it means the mean groups are similar relative to the variation within groups, which means that they are, the differences are within what we would expect if it was just random chance. Now, it can be a little hard to know, right? What is a good and a bad F statistic? Because what we need to do fundamentally here is reject the null hypothesis. So how do we reject the null hypothesis? Just like we've always been talking about, we're going to look at our sig, our p-value. So if our p-value is below 0.5, that means that the significant differences in the table are statistically significant, which means that it's good. We like this. It means that we have found a significant correlation between our variables, right? If they are above 0.5, this means that there are no statistical significances, which means that the differences we observe are likely due to chance, and therefore we can accept our null hypothesis. Okay. Right, so this is quite important because this is the type of test. So the other tests that we've looked at are very basic tests that you can do in statistics and when you write your reports, when you do your studies. But ANOVA testing is considered, your standard reliable test that you should do when doing bivariate data, and is considered very important for young researchers to have a strong grasp on. Okay, so because that is true, let us take a moment and actually talk about, let's field some questions about what the ANOVA test is and whether this ANOVA test is showing us what we want to see. So does everyone understand what our ANOVA test is and whether it's showing us a good, does it make sense, the ANOVA test? Okay. All right. Okay. So I'm guessing there are no questions.
Hi, Stephen. Yep, there's
ahead.
no questions in the chat, and I'm not seeing any hands raised. Colleagues, if you have a question for Stephen, the floor is yours. If not, then you can continue, Stephen. I'm not seeing any hand and any question in the chat.
Okay. So
Thanks.
before we go on, all right. So if variances are unequal, right? We want to use a Games and Howell test. So a Games and Howell test is a post hoc multi-comparison test, right? Used after this is complete. So it's basically, where is it? Okay. Right, okay. So this test is run when the assumption of equal variance is violated, right? The variances are unequal across groups, so the group sizes are unequal, right? It helps you control for the type 1 error rate, which we talked before, and adjust for unequal sample sizes, right? It's going to adjust the p-values and confidence intervals, right, between the groups. Okay, so that's quite important to do when the Levy's test for homogeneity is greater than 0.5. Right. Okay, and you can get to it It's just right here. You see where it says post hoc there. You'll click there and you'll select the games and Howell test. Quite important to do that. I just wanted to mention that before we go on. Okay. So now we're going to go to the two-way ANOVA. So the two-way ANOVA is very special, right? Because it is an advancement on our original ANOVA. And we really want to use this a lot in our analysis. Okay, so what is the two-way ANOVA? Okay, so this is a statistical test used to examine the effect of two independent variables, also called factors, on a single dependent variable, right? It also assesses whether there is an interaction effect between these two variables, meaning whether the effect of one factor depends on the level of the other. So the main thing it does is test the individual effects of each independent variable on the dependent variable. Test whether the two factors combine in a way that influences the outcome differently from each factor alone, right? This is what I talked about a little bit earlier when we say you have a third factor when looking at the relationship between the two variables, which might influence that relationship. This is one of those tests that you're going to be doing. Okay, so it's a more complex design, right? When we're testing two factors simultaneously, it's going to see if the factors independently affect the outcome, right? It just see if a combination of factors creates unique effects. And it's more effective than running multiple one-way ANOVAs separately, which is what you would do when looking at the effects between different variables. So let's use an example to try and understand what we're talking about here. So imagine a study affecting the diet and exercise level, right? So you have a diet type A, you have diet type B, and then you have exercise level, right? You know, how much you exercise. Do you exercise a lot? Do you exercise a little? So these are two factors. So why do people do diets? Why do people do exercise? They do them because they want to lose weight. So our third variable, our independent variable, would be weight loss. So what can a two-way ANOVA tell you about the interaction between these three variables? It can tell you whether diet type, so diet type A, you only eat vegetables. Diet type B, you eat maybe lean meat and vegetables, for example, affects weight loss, right? So the main effect of diets, right? Whether exercise level, do you exercise a lot, do you exercise little, affects weight loss, again, the main effect of exercise, and whether the effect of diet changes, right, depending on exercise level, affects weight loss, which would be the interaction effect. Very important, the interaction effect. Right, so let's look how we set this up in SPSS. So we go to our analyze, and then we go to our general linear model, and then we select univariates, the univariate command. Okay, so the univariate command is used to perform tests when you're studying one numeric outcome and how that's affected by different categorical variables. And the two-way ANOVA is one of those different types of test. Okay. Right, so then what's going to happen is you're going to see this box, this selection box. It's going to come up right here. And you're going to move your dependent variable, right? So when we talked about weight loss, right, we're going to move that here where it says independent variable. And then we're going to see fixed factors, right? Again, what does it talk about factors, right? So factors are just independent variables. That's what factors are. We can move those in there. So remember from our example, we talked about exercise, we talked about diet type. Okay, right? So by default, the model is going to include the main effects and the interactions of your factors, right? You want to check to confirm that the interaction is included, okay? Now, before we go ahead with the test, there are certain assumptions that we are making when doing this test. When we do all tests, we are making certain assumptions. It's very important to be aware of what those assumptions are. So the dependent variable is continuous and normally distributed, right? The groups have equal variance, homogeneity of variance, and the observations are independent, okay? So those are the important things. Now, there's a whole bunch of ad hoc tests that you can run. We talked a little bit about ad hoc tests when we talked about the one-way ANOVA. The ad hoc tests you can run here are very similar to those ad hoc tests. Right. Okay. Then there is covariance. Now, covariance we're going to talk about in a minute. I want to really go through how to do your basic two-way ANOVA, and we're going to come back to covariance. Okay. Right. So let us look now at the results of our two-way ANOVA test. Right. So first
Hi,
we're going to look
Stephen.
at the, oh, sorry.
Yeah, quick one. While you are still on the results, I think we have a question that might fit in well here.
Oh, perfect. Let me go back.
Yeah, we have a question around why is the Welsh ANOVA considered more robust than the traditional one-way ANOVA?
Okay. So let's go back there. Wait, no, sorry. Here we go. Here we go. See, that is a very important question. Okay. So the Welsh test is not a that's part of the ANOVA test, right? It's an ad hoc test which shows us that to show us how viable our one-way ANOVA test. So we shouldn't think that the one-way ANOVA test is different, right, from the Welsh test. The Welsh test is a post hoc test done to confirm the validity of our one-way ANOVA. Okay, so why is it a good thing to do? Because often, in very practical terms, you are working under conditions of heterogeneity of variance. Right? Now, the one-way ANOVA assumes homogeneity of variance, each group having similar variances. But when you're working with real data, more often than not, that assumption cannot be met. Or it's not met to its ideal degree, and you want to use the Welsh test just to correct for that. The main thing it does is that if that test is violated, the homogeneity of variance test is violated, this will mess with your p-values. So the degree to which you can reject or accept the null hypothesis. Now, given how important p-values are, it's very important that we have a test that allows us to be very sure that we have reliable p-values. Right. So that's why we would use the Welsh test, because often in real terms, when working with real data, there's a lot of heterogeneity of variance, especially with data sets which are a bit smaller. Then that's going to be an even more pressing issue. Okay. Right. Yes. Have I answered your question?
Thanks, Stephen. Yeah, I think Huzaifa might have a follow-up, but let's take it that you have answered the question correctly, and we can move ahead. We'll just check the chat to see if he has a follow-up question. Thanks.
Perfect. Okay. Right. Let's go forward. Okay. Here we go. Right. Okay. So we have our results. This is what the results look like, more or less. Again, we don't have to go through each of these numbers and distract ourselves. We just have to talk about the broad strokes, which is the most important thing. So we're going to look at the between subjects effects table, which is this table right here, right? And we're going to check the P, we're going to check basically, look, you got your N, you got your variable. Isn't that great? You can see really what we're actually looking at here. So this is a good thing to just make sure that the data presented in your tests of between subject effects, which is this main table here, is actually representing the data you should be looking at. So if you made an error in how you've inputted the data, this table right here will show you that, because it shows you the raw numbers. Again, if you've made an error, you check that. Now you make sure there are no errors in this raw table, which just shows you the variables and the numbers you've inputted. Okay, now we're going to check for our between subject effects table, right? So the main thing we're looking for here are the p-values for each factor and the interaction between the two factors and whether that is significant. You can also see there we are going to have some very, very important and significant variables, because you can see all the different interactions we have. Now, what is the most important thing to look at would be here, your significance table, and there your F statistic. So you want to look at the p-values for the main effect, right, variable, and you want to look at the p-values for the main interactions that you're very, very interested in. Okay. So that's just, what else do we really need to know for this two-way ANOVA? Because I'm quite conscious of time. All right, let's just have a look, because it can be a little confusing, because I just want to go through covariance a little bit. But let's think about what we should be talking about right now. Okay, so what we're going to see when we do this analysis is you're going to see the Levin's test of equality of error variance. So you need to check that and make sure that is consistent with our key assumptions, which is that, the assumption of equal variance are met. And usually this happens when our p-value is over 0.5. Okay, so okay, we talked about that table. We're not going to talk about that. All right, I want to talk now about covariance. So covariance in your ANOVA table, right? And then after that, we're going to do some Q&A. And then we're going to see if there's anything we want to talk about. I'm also going to show you a series of practice data sets. So you can download those data sets and run a series of practice analyses on them. They're very good for doing tutorials and doing small group assignments. It's very, very nice to use. And if we had a smaller number of people in this lecture, then we could have probably done some kind of tutorial thing. Okay, so let's go back and talk a little bit about covariance, and then we'll basically finish up, because I see we're very close to the time. Okay, so covariance, they're right here. So covariance is a continuous variable that you include in a model to control for its influence on the dependent variable. It's not a factor that you're directly testing, but may affect the outcome, right, of your analysis, and therefore you want to adjust for it. So Basically, some factors may be what we call in statistics confounders, right? And therefore, you want to control for them when doing your two-way ANOVA. And removing these confounders by controlling for them as covariates allows you to isolate the effects of the main factors that you're interested in, right? Okay. So, for example, if we are looking at diet and exercise and their effect on weight loss, we might want to control for factors that may be confounders here, such as gender, because there are biological differences in the response of female and male bodies to to diet and exercise and attempts to lose weight. The similar for age is another important one. We want to put age there. People's bodies respond differently at different periods of age to diet and to exercise. So very, very important there. Okay, so now this example here did include some covariance, right? So what you want to do with the covariance is just you want to see if it is, again, significance below 0.5, right? If it is below 0.5, you know that that measure impacted on the dependent variable, right? And because you've included that measure, right, in your analysis, all your other variables are affected by that inclusion, and therefore your results are cleaner. So its significance would be this right there. Okay, so I just want to go through this one more time very, very quickly. So a covariate is a continuous control variable, right, included to help remove confounders in your two-way ANOVA, right? So two-way ANOVA tests two factors on a continuous outcome, right? So here we were using the example of weight loss, but it could be any continuous variable, age, income, etc., right? Now, there are certain post-hoc tests you can run, but I'm quite conscious of time, and I just want to talk to you a little bit about something before we go on. So these are practice data sets. So practice data sets are data sets that you can download for free, and you can use them as much as you like with SPSS. All these have SPSS in them. They have the file usage format there, and you can download these and you can practice with them, and you can look at different tests, you can select different outcomes, and they're very, very good. Also, if your research is secondary analysis, this would be analysis that requires you to analyze data that's already been analyzed. You can use some of these. One of the more interesting ones is the South African Social Attitude Survey, SPSS. This is a public opinion survey data set that the HSRC puts together. It's freely accessible to anyone. You can download it. You can look at all the different data on there, and you can produce academic papers and research reports for your own interest as scholars. There's no restrictions on how to use the data, and it's very helpful for young researchers who want to do secondary analysis. But also all these are, and the ones above are more standard tests, survey instruments from international sources that can be used for practicing your statistical skills, and they really do help. So we have about 10 minutes left in this session. So I'm going to open the floor to questions. We have a bit of a dialogue before we end. And I just want to thank you very much for your participation in this lecture. I know that we can make improvements, and I'd love to make improvements for the next round of things, and we're always looking to shake things up. The way we're doing this way is because of how things went in the previous seminar. So we can always do things differently every year. So I'd love to hear feedback from you guys, have a bit of a discussion, any questions you might have. We have some time, so please let me know. Right.
Hi, Stephen.
Oh,
Quick
hello.
question in the chat. Annelies asking if there's time to talk about multiple variance regression analysis and if can SPSS calculate the G power for a sample size from a large group.
Okay, so that's perfect. All right, so I'm going to talk a little bit about what multivariate regression analysis is, and then I'm going to talk about how to run that on SPSS. So we talked a little bit just a second ago about confounders. So your one-way ANOVA test is a bivariate analysis looking at the relationship between two variables. Your two-way ANOVA test looks at the relationship between two variables on one dependent variable and allows you some ability to control for, right, or to take into account confounding variables. But these tests are great, but the gold standard here is what we call multivariate regression analysis. So multivariate regression analysis, what that does is it takes into account a large number of different variables and allows you to isolate the effect of each one on your main dependent variable. Right. So let's just talk about how to do this in SPSS. Okay. So very easy. You go to analysis, you go to regression, and then you would select the regression analysis best suited to your dependent variable. So remember, we talked about dependent variables before. So certain dependent variables need to be analyzed using certain tests. So for a continuous variable like age or income or weight loss, we want to use a linear regression analysis. But for other variables, such as a ordinal categorical variable, you want to use an ordered regression analysis. Logistic or probit is very good. Now, if you have a binary variable, so a binary variable is 0, 1. So usually these are good for yes/no questions or for questions where there's only two answers. Then you can run a binary regression, right? Then finally, we have normal regression analysis. Normal regression analysis is a little complicated because it is the way the regression analysis produces its data depends on its ability to compare one category with another category while keeping all the other categories to the side. So that explanation just tells you that it can be a little complicated to do, and that's called multinomial regression analysis. Right, so this can be done with SPSS, right? And it is quite a complicated set of analysis and is not really for beginners, but there are lots of tutorials online which will show you how to do this. There are textbooks, there are more advanced courses. So if you want to do that type of analysis, it's above beginners, is what I'm saying. But it definitely can be done. Yeah. Okay. So are there any other presentations? Why am I saying presentations? Are there any other questions you would like to ask?
There are no more questions in the chat box, Dr. Gordon.
Okay, right. Okay, what do we want to say here? So what I've done today is very, very basic. It's very basic stuff that we've done, and just very, very simple stuff that we've gone through. Because again, this is beginners. This is a beginner's course. This is not for more advanced people. There are lots of tools online which will allow you to which will help you run this type of analysis. Now, I'm going to give you some advice on how to look for this type of thing online. Okay, so when you first joined orientation way back when, on Monday, my colleague Michael Gastro gave you a bit of a talk on AI, generative AI. Now, generative AI is not particularly something that you should worry too much about in terms of its usage. The main thing you need to worry about is, how do I use generative AI to analyze quantitative data? Now, you can ask generative AI software, ChatGPT, DeepSeek, Perplexity AI, free software tools, Gemini, how to perform certain tests in SPSS. And SPSS will give you a step-by-step guide in terms of how that's done, right? So SPSS can also write you code, for example. If you ever sit down in front of something and not know how to write code for it, SPSS can also, generative AI can also do that for you. So that's one thing to do. It's very, very useful. And that really will help you a lot, I think, if you're struggling with how to do something. The main thing to do with a piece of software like SPSS is just use it a bunch of times, and you'll develop a type of muscle memory, and then you'll be able to analyze data in a very quick and steady way. The second thing is, you really need to understand all the different sort of tests and the theory that goes behind these tests. So if you think about this lecture, we spent a lot of time talking about why you would do the test, right? Not so much about what the actual numbers are saying, because the most important thing is to understand why you do the test and what the test should show, not so much what the test actually does show, right? Because figuring out what the test shows, that's your job as the researcher. The knowledge you need to have to understand the test, that's what people should be teaching you, is what should be happening, what should you see, not what you actually do see. And because the comparison between should and what is in front of you, that's your job. Why are we seeing a difference between what we should see and what we actually see? Or we are seeing what we should see. Why are we seeing what we should see? Okay, I see there are some comments. Let's see if here we go. Right, so let me talk about SPSS and how to download it. So SPSS is a licensed piece of statistical software. Your institution will provide you with SPSS. It's not really designed for private researchers it's really designed for institutions. You can, of course, download SPSS and get a license yourself, but it can be very expensive. Okay, and I see there's a question here. So is using SPSS easier than using qualitative data? So the key about SPSS is it can analyze quantitative data, so what we call string data, but it's designed to analyze numerical data. So if it ever does analyze qualitative or textual data, it's going to analyze it in the same way that it analyzes numerical data, because it's designed for analyzing numerical data. So it's not really, a lot of people think that using quantitative research methods are very challenging and very difficult, but it's no more challenging and difficult than using another type of research method. It just means that you have to learn the different theory and methodological theory that lie behind all the testing that you're doing. And in that way, it's no different from qualitative research, in which you also have to do the same thing. So in qualitative research, you have to learn why you do focus groups, what are the different methodological criteria and assumptions that exist behind those, how to quote people, what does this mean, how people make connections. So much in the same way that you would do that with qualitative data, you have to do that with quantitative data. Right. Are there any other questions before we close for today?
There don't seem to be any questions, Stephen, from both the chat and the floor. Yeah, there's no questions.
Okay, excellent. Well, thank you guys very much for your participation today. I hope it wasn't too boring, and good luck. I think this is one of the last tracks for the Academy. So thank you for those of you who've stuck with us until the end. Thank you very much, and I hope you have a great day.
Thanks, Stephen. On behalf of everyone, the HSRC Academy organizing team, I would like to thank all the participants for today's session, and I hope the presentation by Stephen has enhanced your understanding and at least given you practical ideas and support for your data analysis, especially those who are considering postgrad studies or those who are engaged in postgrad studies. And a special thanks to you, Stephen. I think you have led a great presentation, insightful and engaging. And I think your expertise and clear explanation made this quite brilliant presentation. And as we conclude, I would like to remind the participant to please complete the feedback form. I've shared it in the chat to give us ideas and input on how to improve our delivery into the future. And of course, we encourage you to continue exploring SPSS and applying what you have learned today. We have also shared the presentation by Stephen in the chat. So you might want to go there and go through the slides as you are practicing on your own. And of course, if you have follow-up questions, please reach out. We will be here to assist in terms of trying to get you access to some of the material. And with that, I would like to officially close the session and wishing you all the best and good luck. Thank you.
Thank you.
Thank you.
Thank you.
in social and health sciences research. His areas of research interest include automated zone design techniques, geocomputation, geo-AI, small area estimation, accessibility modeling, spatial analysis and modeling, spatial statistics, data analytics, demographics, and sampling techniques. Dr. Mokele's publication record spans the authoring and co-authoring of more than 60 peer-reviewed journal articles, books, book chapters, conference proceedings, and policy briefs. Our second presenter today is Dr. Emmanuel Fundisi, who is a seasoned geo-AI researcher and geospatial specialist at the HSRC, associated with the Geoanalytics Department. He holds a PhD from the University of Johannesburg with experience in remote sensing, GIS, machine learning, deep learning, and big data analysis, and he is a registered professional in geospatial sciences. Dr. Fundisi specializes in GIS, remote sensing, and machine learning, particularly with a focus on analyzing spatial data using big data mining and deep learning techniques. His recent research contributions include methods for small area estimation of HIV/AIDS prevalence in South Africa, spatial determinants of HIV risk behaviors. Dr. Fundisi has published multiple peer-reviewed articles in science areas spanning biodiversity monitoring, urban land use, mapping, and public health analytics. So we have two very experienced doctors as presenters for you for the session today. I hope you enjoy the session. Please remember to download the QGIS software, and also feel free to ask questions in the chat and then engage in discussions with our presenters. Thank you so much. Tholang and Emmanuel, you can go ahead. Sorry, Tholang, you are muted.
Thank you very much, Sylvia, and for a warm welcome and introduction to the session. Colleagues, as indicated, I'm Tholang. I'll be presenting together with my colleague, Dr. Emmanuel Fundisi. And I'm just switching off my camera now, but I'll switch it off throughout the training, just so that, you know, colleagues can ensure that they are not speaking to, or they're not working with the AI robot or so. And welcome to the sessions. And I think we're looking forward to an interesting sessions together. I think, Emmanuel, you can just show yourself if you are camera ready, so that we can proceed.
Yeah, can you see me?
Yes, we can.
Good afternoon, colleagues. My name is Dr. Fundisi. I'll be assisting Dr. Mokele in this endeavor. Thank you.
Are there any colleagues who have not yet downloaded the QGIS software? Afternoon, colleagues. Is there anyone who have not yet downloaded, or are we good to go?
There are a couple of people, sorry, there's a couple of people who are still downloading it. I'm sorry for interrupting whoever was speaking. Please go ahead.
Good afternoon. I was just informing you that I'm unable to download due to connection issues.
Okay. That's fine. For those who are not able to download, it's fine. You can always do it after, because I think we'll be moving more on a demo type of session. And then if you can't keep up now, you can always do it at your own pace at a later stage, because there is a manual that you can follow. Okay.
A quick question, kindly. Which of the, I'm seeing so many of those softwares of the GIS, which one are we downloading in particular?
You are downloading the QGIS one.
When I open, I'm seeing, I don't know, something called long-term version for Windows, latest version for Windows, experimental.
You download the long-term version.
Long-term version for 3.40 LTR.
Let me just share my screen to make it easy for you.
Okay, thank you so much.
Okay, can you see my screen?
Yes, we can.
Yes, but that's not what my link is taking me to.
It's taking you to what?
Let me just try using the same.
Let
you
me click
sent.
from my side and then you will tell me if, and then I'll just take you through, but to some extent, because I can't go further as it will force me to, then you just skip this donate icon. Have you passed that stage? Are you not here around this space?
Sorry, minute.
So you choose this one, long-term version. Because the challenge with this one is because it's an open source, there are some experimentals that are still taking place there and it's not stable. So the long-term version, it's always the stable one that we
Okay,
normally
okay, yes,
consider.
I've seen that one. That's what I clicked.
Yeah,
That's
so you
okay.
just choose the long-term one. Super, is that fine?
Yes, it is, Doctor.
Okay.
Thank you so much.
So as indicated, colleagues, our learning objectives for today are that, at the end of this session or this module, you should be able to have some, basic knowledge about the GIS applications, especially in the social science environment. And then we are also expecting that you have some, basic understanding of how to use open source GIS, QGIS, which is quantum GIS, to create some maps. And from there, would like to have some understanding of how can you incorporate the geographic information system into your research areas or project, or even the thesis, if you are working on the thesis for our postgraduate learners. Okay. I'll try to play some video here and see.
Hi, Talang. Sorry, we just have a comment in the chat saying that there seems to be a fee to pay to download the app. But I think it is a free version.
It's free version. You skip this donate. It's not you donate if you wish, but you skip that. You click skip donation. Yeah.
Okay, perfect. Thank
Just let me know if you can get the sound, eh? Are you able to hear?
No, we can't hear anything
No
yet.
sound.
Well, is Maxwell still here?
Yes, doctor, I'm here.
Yeah, I'm trying to play this video, but they can't hear the sound. Okay, can you assist if possible?
Okay, just a second.
Let me stop sharing.
But can you hear the sound on your side when you play
Yes,
the
yes,
video?
yes, it's loud and clear.
Okay, try to share again. When you do share, choose the option that say share sound. No?
Sorry?
When you share, please make sure that the option of sound is ticked.
Okay. Let me do that.
Optimize video with sound or share sound.
Oh, okay. Can you hear now?
Can you move it forward a little bit? No.
Maxwell, perhaps Tolang can send the link to you and you can try and play it from your side.
Okay, please.
Yes, or alternatively, we can pass it because we have shared with the colleagues, they can play it on their own time.
Oh, okay, okay.
Do you want to try from your side?
Yeah, you can share a link with me.
Okay, let me. I've sent it, Maxwell.
Okay, I'm opening it. You send it on the chat.
No, I've sent it on your HSRC email.
Okay, okay.
Dr. Tulang, while we're still waiting for the video, we have a question in the chat box from Mafunza. He's asking, or she is asking, please recommend sources of free spatial data, especially raster images and DEM.
Dr. Gee, can you advise on that one? Hi, Emmanuel.
Hi, Maxwell. Are you having any luck with the video?
Yes, it just came in through now. We are downloading it. We'll play it now.
Okay, great. Great, thank you.
From mapping to analysis, you'll learn how we use GIS to model the world around us. Let's get started. GIS stands for Geographic Information System.
Yeah,
is it playing with the sound? Okay.
Yes, yes. Thanks, Max. Can you just make it full screen?
Okay.
Systems. It's a computer-based tool that examines spatial relationships, patterns, and trends in geography. Using a GIS allows you to store, analyze, and visualize data for geographic positions on Earth's surface. There are four main functions of a GIS. First, a GIS has a data management component for storing geographic locations. Secondly, a GIS visualizes geographic data typically using maps. Thirdly, GIS software can analyze spatial relationships and patterns using geoprocessing. And finally, a GIS can either create new data or edit existing data. Let's take a look at each of these four functions. At number 1, we're going to look at the role of data management in GIS. Data management in GIS is the process of organizing, storing, retrieving, and maintaining geographic and attribute data. GIS data consists of either vector data or raster grids. First, vectors are points, lines, and polygons with vertices. For instance, administrative boundaries are often represented as polygons, whereas something simple like fire hydrants is stored as points. Roads are a good example of line data. The other type of data type is raster. For example, satellite images, aerial photographs, and digital elevation models are examples of raster data. We also call it grid data, because it's represented as rows and columns. We use these two data models every day in GIS. Each type has its own strengths and weaknesses, and is better suited to different kinds of spatial data and analysis. At number 2, we have visualization. Let's say you have latitude and longitude coordinates in a table. I think you can agree that it's really difficult to know where those locations are. But once you show the data on a map, it provides geographic context so you can fully understand where these locations are in the real world. GIS works with these physical locations instead of tables, and we map it all out. Here are some of the most common types of maps. Choropleth maps use shading or color to represent data values for different regions or polygons, such as visualizing demographic or socioeconomic data. Heat maps use shading to represent the intensity or density of data values in an area. Heat maps are often used for visualizing spatial patterns in data, such as crime or traffic density. An isoline map is a type of map that uses contour lines to represent data. They connect points on a map that have the same value, such as temperature, elevation, or rainfall. At number 3, we're going to look at geospatial analysis. The purpose of GIS is to analyze geographic relationships and patterns using geoprocessing. Geoprocessing can be used to perform a variety of tasks, with a focus on extracting meaningful information from geographic data. For example, a GIS can identify the shortest route between 2 points, or it could create buffers around features. It can also overlay different data layers to identify spatial relationships, and conduct statistical analysis on geographic data. They say you don't truly know your data until you can visualize and analyze it geographically. Through spatial analysis, you can solve location problems to measure, quantify, and understand our world better. And finally, at number 4, we're going to look at the role of GIS editing. GIS data is a key component in the development of accurate and effective applications, because without geospatial data, the field of GIS wouldn't exist. Editing involves building new data sets from the ground up or updating existing geographic data. It's important because it ensures that the data being used is accurate, up-to-date, and relevant to the problem at hand. Now that you have a bit of background on what GIS is all about, let's take a closer look at some of the most common types of GIS jobs. If you're just starting out in the field of GIS, you'll likely start as a GIS technician. This role involves most of the grunt work like data editing and map production. The next step above this level is either a GIS analyst or specialist. Both types of roles typically are heavily involved in geospatial analysis, and it may involve data modeling and coding. Another common job in the GIS field is a cartographer. Cartographers specialize in creating visually appealing map products and communicating this information. Finally, GIS developers strictly work at code development. This might be for the purpose of automating workflows of building customized scripts that perform a specific task. Although it's seen its fair share of twists and turns, GIS has steadily increased in demand and is becoming more mainstream in various industries around the world. We use GIS in a wide variety of applications across many different industries. Here are some of the biggest users of GIS. Urban planners use GIS to model and analyze urban land use, transportation, and infrastructure. This helps planners make informed decisions about development and growth. Environmental management leverages GIS to monitor and manage natural resources, track species habitats, and predict the effects of climate change. Emergency management uses GIS to manage and respond to natural disasters, disease outbreaks, and other emergencies. Marketers use it to help businesses target their marketing efforts by analyzing demographic data and consumer behavior patterns. In agriculture, GIS can optimize crop yields, manage land use, and monitor soil and water quality. In energy management, we use GIS to manage and optimize energy distribution networks, monitor energy usage, and identify opportunities for energy conservation. There are countless ways where we are using GIS to improve efficiency and make a difference in the world. As technology evolves, so does the entire industry of GIS. Here are some of its current and future trends. Mobile GIS has really been mainstream for a long time already. Because of the increasing use of smartphones and tablets, mobile GIS enables users to access and interact with geospatial data from anywhere, using mobile devices. This is leading to new applications in areas such as field data collection, asset management, and emergency response. Open data and open source GIS software are also mainstream now. Open source software like QGIS provides access to a wealth of geospatial data and tools at little or no cost. In addition to open source software, we are seeing more open data portals which are common in all levels of government. Cloud-based GIS services allow users to store, process, and access geospatial data in a highly scalable and cost-effective manner. Cloud-based platforms offer flexible computing resources and easy access to a wide range of geospatial data. With the explosion of big data in GIS and the increasing availability of AI and machine learning tools are transforming the way we analyze and visualize geospatial data. These technologies are helping to unlock insights from vast amounts of geospatial data. Finally, we have 3D data. With the increasing availability of 3D data and visualization tools, it enables users to visualize and analyze data in a more realistic and immersive perspective. All right, there you have it. That was our definition of geographic information systems. Now, we'd love to hear from you any questions you might have in the comment section below. Also, please don't forget to like and subscribe to our channel for more great videos. See you next time.
Thanks, Maxwell. Thanks, colleagues. I think, you can, listen to that video so that you can, learn more about GIS as indicated. So I think we'll move straight to our demo session where we are going to demonstrate how we use QGIS. Let me share my screen. Okay. Is my screen visible?
Yes, we can see it.
Yes, so first of all, we learn how, like just the basics of how to open the QGIS blank map, adding layers, adding polygons and points, and then how do you manipulate their symbologies or change their symbology to fit the requirements of your requirements or the requirements based on the journal or the book that maybe you are working on. And then from there, we'll try to explore the attribute table in terms of how can you, start understanding the data that is behind the map that you are working on. From there, we will just go through some basic statistics using, QGIS. And then we'll also learn how to remove a layer from a list of layers in QGIS. And then, of course, we'll also learn how do we select features, and then how do we create a layer from those selected features. And then the final step will be to see how can we create a thematic map using QGIS. So before I open a blank map, I think I just want to, colleagues to familiarize themselves with like, the bars that we have in QGIS. We have the menu bar, we have the list, the layer list. This is where we normally list the layers that we'll be working on. And then we also have the attribute toolbar where you can, do your zoom in or zoom out, and then the labels toolbar. And then we also have our map canvas here. This is where we'll see our map showing as we add the map. From there, we have your status locator, status bar, and then we also have like your locator bar. So those are the key things that will be, playing around throughout this session. So I just wanted to show colleagues that before we can start with opening the map. So for us to open our QGIS map, for those who have downloaded, you can just go to search icon and then just type QGIS. And then you double click it. Okay. It's opening, takes some time. Okay. So this is our, QGIS, open environment. So then for us to get a blank map, we go to this icon here. Then we say new project. Okay, and then this is the area where we can now start adding our layers. I just want to move this. Okay. So our next step is to, how do we add these layers that we are talking about? As it was indicated earlier, you have your vector layer, you have raster layer, but today we will be working mostly with the vector layer. Okay. So how do we add the layer? We go to this icon, which is like open data source manager. Once we are there, we can be able to click. And then it's always key to remember where you have saved your data set. And then from there, here we'll browse and locate where we have saved our data set. In my case, I saved it under C drive data. And then for those who have not yet downloaded, they can even do that afterwards and then play around with it, because there are steps in the manual that you will follow. But for now, let's move together and see how we do it. So we are saying you go to data source manager, and then you choose vector, and then you browse, you locate where you have saved the data. In my case, it's under C drive data. Okay. So our first data set that we want to add on is our provincial data set, which is under admin boundaries. So we just double click here, and then we look for shapefile for province, and then we click open, and then we add. So as you can see, now we have our map showing on our map canvas. Our colleagues who have downloaded able to see this on their site. Anyone who has successfully added the data? You can just show by show of hands, and then Tina, you'll indicate if you see anyone. As I'm sharing my screen.
I'm saying that they have saying yes, but there's a comment from Nancy. They are saying that you're going too fast.
I'm going too fast.
Yes.
Okay. Let me remove it so that we go back again. Okay. So we are saying for us to add the layer, we go to the data source and open data source manager. We click there, and then we choose vector. Remember, I said we have vector or raster data, but we are going to deal with vector data today. So we choose vector data, and then once we have chosen it, you browse and locate the data set that you are going to work on. In this case, we are saying we are going to add a province layer, which is under administrative boundaries or admin boundaries in the folders that you have. And then once you have clicked there, then you look for a shape file. So in this case, we are going to take our province shape file, and then we click on it, and then we click open. Then after that, we add it. So, and then we click close. So once you have added it, it will show on your map canvas. Can we move to the next step?
Yes.
Okay, super. Okay. So now the next step is to say, now we have seen how we can add our layers, or in this case, our shapefile, which is the province or the provincial boundaries. So then our next layer is to start, looking at how do we add points, how do we, add lines and polygons. In this case, our province represents polygons, and then we'll add few layers that will, like we'll add roads for lines, and then we'll add hospitals for points data. Okay. So let's add hospitals. For add hospital, we follow the same process. Open data source manager, vector, and then we browse. In this case, we'll go out so that we go to hospital. Okay, so under hospital, we'll choose our shapefile again, hospitals shapefile, and then we add. As you can see, now we have points data showing in our South African map. We have like a list of hospitals that are showing, or even the distribution of hospitals that are showing across the country. So this is our points data, because it gives you the location of where these hospitals are located. And then with regard to the line data, we are going to add the roads data. We follow the same process. Open data source manager, we choose vector, and then we browse, and then locate where is our roads data. And then we choose shapefile, and then we open, and then add. We can now see that our lines data, our roads are showing. These are our national roads across the country. Your N1s, your national road, N1, N2, N3, and then N4. Okay. We can also add the district boundaries just to show how to add the polygon. Okay, we go out under admin boundaries. We add the district municipalities. Okay. You can see now in our list, we now have the district municipalities, national roads, hospitals, and provinces. Now, when it comes to symbology, or like different key colors, as you may see now, the province and district, they are having both. They are both having same symbology or same color. So in essence, one cannot see where certain provincial boundaries ends, and how can you differentiate between the provincial boundaries and your district boundaries. So that's when your symbology becomes key, because you want to use it to be able to differentiate between two different layers. Let's first start with the hospitals. You can move them up here because now we can't see them. You can drag them up so that this layer is visible. Okay. We want to change their color so that they are more visible. Okay. So let's change them to a blue color. So we right click on hospital. And then we go to properties, and then we choose symbology. And then we choose the blue dot for the blue color. Okay. And then we click OK. You see now our hospitals are showing in blue color. But however, you can see the sizes of the dots are now too big to a level that, where one can, see properly in some cases in terms of the boundaries that are behind these hospitals. So we'll need to sort of like rework on this symbology, maybe reduce the size of the dots or the size of the point. So we go back to properties, then symbology. And then in terms of the size, we can reduce it and make it 2 instead of 4. Just delete here and make it 2 instead of 4. And then we apply, and then we click OK. Can you see now that we have reduced the size? At least our hospitals are, back to normal, and the layers behind them are visible. They are not sort of like blocking the roads and everything. Okay. So then our next step is to say we are now seeing that, for instance, as I indicated earlier, we can't see the difference between the district and the provinces. Okay. For us to be able to do that, we still follow the same route of changing the symbology. So based on our manual, we have to change our district municipalities to green, and then change our provinces to black outer boundary. So we go there and say properties, okay, because we want it to have, hello inside. Then we from here, because we said we want black, we are going to choose black color here for our boundaries, and then we click OK. So our provinces are now in the black boundaries or outer boundary. So for district, we have to change it to green. So we right click, and then we go to properties, follow the same process. And then this one, you can just choose green. We already have green, so we don't need to work on that, and then click OK. Can you see now that we can even see the roads behind? But however, because the district boundary and the provincial boundary, they are same size, we cannot see the provincial boundaries at the background. So for us to be able to see the provincial boundaries at the background, let's reduce the size of the district boundary. Okay. Go to property. Okay. And then we click on simple line. And then now we can see the stroke width. So we need to change this stroke width so that, let's change it to 0.5. Okay. And then we apply, and then we click OK. And you see now that you can see that there are some, dark or black background behind these provincial boundaries. So one can start seeing that where you have provincial boundaries along here, you can start seeing to say this is, for instance, the Western Cape province boundary. And then you can start seeing this is the Free State boundary, and so on. So it's much more visible compared to when it was same stroke width between the district and the provincial boundary. Are we still there? Can we move to the next step, or should I take it silence means we are following and we are able to do the process?
There is a hand from, please go ahead. Is it-
Yes, can you guys hear me?
Yes.
Okay, so I got a bit stuck. My map just disappeared. And so now I just have a blank canvas, but I have on my layers, there is all the layers ticked, but I don't know where my map went to. And also, I think there was another I also had another question of where do we get this data, like these shape files that you had already saved in a separate file? Like, how do you download them to have them in the software? So those two kind of questions. I don't know if you followed the first one, but yeah, I had my map and I don't know where I pressed, but then it's just disappeared.
Oh, okay. So let's discuss the data sources later, but for now, let's try to bring your map up. So you right click on conference layer, right click.
Right
and then
click.
And then you say zoom to layer.
Zoom. Okay, perfect. Yeah,
Super.
that worked. Thank you.
Okay.
Sure. Thanks.
And let's leave the data sources later for discussion.
Okay, thanks.
Thank you. Okay, so I think let's now change our layer so that it's not as clean as this other as your district. So for us to change that, we go to both layer, then we right click, say properties, symbology, and then can click on the simple line there. And then I think from the instruction, we have to change it to brown color. I think it might sit somewhere here. Yeah. Okay. So once we have chosen the color, what else do we need to do? We need to increase the stroke width. Instruction says, let's make it 1.0. Okay. Then we apply, and then we click OK. And we see that now our roads are in dark brown instead of green like they were before. And we have also changed the stroke width so they are more visible. Are we still happy? Can we move to the next step?
I'm not seeing any hands.
Okay, super.
So
our next step is to explore the attribute table. So what is this attribute table? So as you can see, for now you are just seeing this data as lines. You are seeing these hospitals as just dots. But like in any other database, there's information behind these dots. Like for instance, maybe the GPS coordinates, or maybe to say if it's hospitals, it might have even information in terms of how many people normally use that hospital, or human resource in terms of staff of that hospital. So it depends on the level of data that you have. But let's start by just looking at the province one. So we right click on province, and then we come here and say open attribute table. Right click on province or any layer, and then we say open attribute table. Then we click there. So now we can start seeing our attribute table. As you can see, it's your province code, EC for Eastern Cape, province name in full, Eastern Cape, your province code. Eastern Cape we know is 2, and then we know Western Cape is 1. As you may see from here. So this is what we have, what we call our attribute table. Then we can even start seeing the Albers area, which is like, the size of the province, and so on. So this is what we call attribute table. That's where you can have information or the statistical data about your, you know, your features or the layers that you are working on. Okay, we can also try this one just to explore more the hospital data, and then we go to attribute. Okay, as you can just see here, it shows you the province, the name of the hospital, whether it's a district hospital or specialized hospital, and then the district. So you can have like all that information that you can be able to sort of query or use for your planning, or, you know, in terms of like if you are planning for the whole district or for the whole province in terms of like human resource, you know, allocation and so on, and trying to see how many hospitals are still in operation, how many are closed, and so on. So this is the one that you can play around with, and then from there you can use the software to start querying or doing some running some expression or algorithms to get some questions. Because remember, this one is, it's a little bit it's a small data set, but in some cases you'll be dealing with a massive data set that you cannot just be able to just browse and look for a certain answer. Then you'll have to use an expression or the tool to query and get an answer for that for such query that you are looking for. Are we clear with the attribute table? Can we move on to the next step?
Yes, we can. I'm not seeing any hands up. It's just thumbs up at the moment.
Okay, super. So I'm at the correct pace, eh? I'm no more fast. Okay. So then, based on our manual, our next step is the basic statistics using the survey data. In this case, we'll explore the census 2022 data that we received from SPSS. Okay. So then we will have to add this layer for us to be able to work on it as well. So we go back and then we use our open data source manager function to add the data. Okay. Okay, in this case, we are looking for census 2022 data, and then we add the shapefile, and then we click add, and then we can close. So now we have our data set in this case, which is our census data set. Okay. We can just open our attribute table just to see what information it entails. Okay. For instance, we can start seeing that it has like the sex variable, which is male and female for 2011 census. We also have the same for 2022 census. Okay, and then we also have sex ratio for 2011 and total population for 2022 there. Okay. And then we also have the number of people who recorded who indicated no schooling for 2022 and so on. We also have age category here. So you can see like this is like your actual database that you normally have it either in Stata or SPSS or Excel or database or other database formats. Okay. And you should always try to familiarize yourself with this attribute table, because as you try to do your queries, you'll be depending on the on the, the headings of these or the names of the variables for you to be able to come up with the solutions to the queries that you may come up with. So it's always wise that, especially the name of variables, just to have an idea. Oh, okay, for total population, this is how it's, or for total number of household, for instance, this is how it's written, and so on. And as you may know, like other softwares, we normally use this variable naming because the GIS softwares, in most cases, they accept a certain number of what do you call, like what I'm trying to say, the number of characters, for instance. It will say it only accept up to 8 or up to 9 characters. So that's why, for instance, we have sort of this abbreviation, as you can see, for May to 2011, we have written it like this. Total pop, this is how we have written it, so that you don't exceed that certain characters that are required by the software. But you must always have a metadata whereby you know that what is the meaning of this top pop 11, and then what is the meaning of this no school 2011. So there's always a metadata accompanying this, because like in any other case where you have like your variable descriptions. Okay. Okay, so then let's go to our step of exploring the basic statistics using this census layer. Okay. So as you may see under toolbar here, you have this icon called show statistical summary. Under toolbar, we have this icon, summation icon. And then when you click on it, it will just say show statistical summary. So let's click on that. And then it brings these statistics under the layer list there. But our target is on census, not provinces. Therefore, we click on this browser to choose census instead of province. And then our query or our challenge is to look for the total population 2022 data or field. So this is where we'll choose the field. Okay. We browse down and look for the field that we are looking for. Then we click total pop 2022. And then immediately when you do that, then it starts showing you the statistics. Okay. Sum, mean, and so on. So for us to be able to explore these statistics further, you can click on the icon just close to this recalculate statistics icon, the one that says copy statistics clipboard. You click that, and then you open either Word, New Word, or Excel. In this case, let me do it in Word. Click on New Word, and then you just right click and paste. You see now our statistics are showing here. You can start seeing what is the total pop. For instance, 62 million people, like your mean, your median, and the standard deviation, and so on. Okay, so it was able to calculate such for the count. For instance, you can see that you are dealing with 213 counts. In this case, is our local municipalities. Okay, and then you can also see your quintile 1 and quintile 3 and all that. You can also export it to Excel. You just click Excel, new Excel. and then you paste. So the same the data, you can also get it in Excel. Now you can start seeing your count and all that, summation, mean, and all that in terms of your statistics. So that's how you can explore the, basic statistics using a QGIS. Okay. Are we good with that? Can we move to the next?
Dr. Tolang, there is a question. Please go ahead, Zama.
Okay. Yes, go ahead, Sam.
So the second, while Zama's still preparing herself, the second question is from Zama Poshangosi, is that can the DHS datasets be analyzed using QGIS software?
Yes,
Okay,
the
I'm
answer is
sorry.
yes.
I was struggling with my sound this side. I was asking that you please repeat the exporting to explore the data from Word and as well as Excel.
Okay. But did you see how you get the sum and the statistics? Or did
Yes,
I start from
yes, I did see. It's just that I'm juggling between two computers, so I didn't see that part.
Okay. So just close to this, in some cases we say it's a refresh icon. In this case, it's a recalculate icon. There is a copy statistics to clipboard icon there. Can you see that?
Yes.
Okay. So you click it, and then you open a new Word or new Excel. Once you have opened it, you just right click and paste.
Thank you.
Okay. So you do the same even if you do for Excel, new Excel, and then you right click and then you paste. Are we good?
100%. Thanks.
Okay, thanks. So now our next step is how to learn in terms of because sometimes you may find that you are working with a lot of data sets or a lot of shape files. So the next step is to learn how do we remove a layer or a shape file from this list. In this case, for instance, we are done with the census data set, so we may want to remove it. Okay, so what we do, we right click on that layer that we want to remove, right click, and then we scroll down and choose remove layer. And then, yes, we want to remove it. So you can see now that under our layers list, we don't have census anymore because we have removed it. And even on our map canvas, it's no more showing because we have removed it. Did we see that process? You right click on the layer and then just click remove. Then you'll be able to remove a layer. Okay. So our next step is to, how do we select features? For instance, let's say you want to focus on hospitals in Western Cape or hospitals only in the Eastern Cape or Free State. So how do we get to be able to select only hospitals that are within such an area? So there are different levels of selection. You can select by location, you can select by attribute, you can also select by expression. Okay. So in this case, let's select by attribute. Okay. So we open our attribute table. Okay. After we have opened it, let's say we want to select Gauteng. Okay. So we click there on number 3, and then Gauteng is selected. So you can even go down there where it says show all features. When you click there and you just say show selected features, then it will only show you Gauteng. Then it means Gauteng has been selected. Okay, let's show all features. Okay. So Gauteng has been selected. So now that we have selected Gauteng, we'll also want to see if we can have a separate shapefile that is just Gauteng only. So what do we do? Based on this selection, we can right click on Gauteng layer there under the layers list, right click. Because it's selected, then we are going to say export. So when we export, we are saying export selected features. You are going to say save selected features as. So we click selected features, and then we choose shapefile. History shapefile in terms of like the format. And then file name, of course, is going to be Gauteng, but then you do your browser again. So you have to save it where you have saved other folders. In my case, they are under data. So I open. So under provinces. And then now I want to have a separate shapefile for Gauteng. Then we just type Gauteng for the name. And then like I indicated for the type is shapefile. And then we click save. And then we click OK. Okay. We can even right click on Gauteng, zoom to layer just to see. You can see now we have our Gauteng province selected. And then we have also not just selected, but now we have created a layer that will show only Gauteng. Even if we switch off other provinces or switch off other layers, but this layer will show because now we have it as a layer. It's a permanent layer. Like for the colleague who was asking earlier, this is one of the way of, if you have some bigger data set, you can even start creating your own data sets, like own shape files that you can work through going forward. Let's say your project was only focusing on Gauteng and you had a national data set. So you can sort of extract by selecting that province that you are focused on. And then once you have selected it, then you create a layer from that selection. And then you'll have a database that is only focusing on that particular province that you want to work on. Let me just take back the other layers. Are we still following, or okay, now we have any hands? Now we can move forward.
I'm not seeing any hands at the moment. But
Okay.
there was a question that was posed by Uzama, asking can the DHS datasets be analyzed using QGIS?
Yes. Maybe she might have missed my answer. The answer is yes, it can be analyzed.
Okay, thank you.
Yes.
And again, please go ahead.
Sorry, I was muted. So I'm saying I got a bit lost with the extraction of Gauteng. Could you please go through that one more time? Sorry.
Okay. That's fine. We can even do another province for your sake. Okay. So we are saying we go to province attribute table, and then under it we choose a province of our choice. In our case, we chose Gauteng. Let's say in this case we can choose Eastern Cape. You choose it. Sorry?
Yes.
Okay. And then you can just click on this one and say show selected features, just to ensure that it has selected the one that you want. You see it has selected Eastern Cape. So after that, you go back to province layer under layers list, you right click, and then you go to export. So under export, you say save selected features, because remember we have selected only Eastern Cape. So you click it. Okay, under format here, sometimes it may come as your package. You choose E3 shapefile. And then under, you browse here to save it where you have saved other data sets. So in this case, in my case, it's under it's under C drive data drive. Then when I got there, from there, then you select province. So you save it under province. Then you can just say Eastern Cape. But in your case, you have selected Gauteng like we did. So we're just trying to show you Eastern Cape. And then we click save. And then after that, you say, okay.
Yeah, makes sense.
Direct.
Got it. Yes, thank you.
Okay, let me remove it because we don't need it per se. Okay. So now our next step is how can we, for instance, like I was making an example to say that you want to focus on maybe hospitals in Gauteng only. You just want to work around that. Whereas we have been given a data for the whole country. Because for instance, when we open the hospitals layer, in terms of the attribute table, it's actually showing like the whole country. You can see Eastern Cape hospitals. If you sort by ascending here, you can see Western Cape hospitals as well. But in our case, we just want to focus on hospitals that are in Gauteng province. Okay. So how do we do that? For us to be able to do that, we have to select by location. When we select by location, we will be selecting hospitals that are only in Gauteng province. So what we do, we are going to select hospitals that are within this layer called Gauteng, meaning we'll be focusing on selecting hospitals that are within Gauteng province. Okay. So what we do, we go to factor, and then we choose research tools. Then we scroll down to select by location. So we say factor, research tools, select by location. Okay, and we said we want to select our hospitals that are within Gauteng. So in terms of the target features, we are targeting our hospitals, which is already selected. But in our case, we are saying we want to select those that are within the Gauteng province. So we uncheck this intersect or touch, and then we click within. And then in terms of by comparing to features from, so here we are going to choose Gauteng layer because we want to select only those that are in Gauteng province. So once we have done that, we can now run our query. Okay. And then after running it, we can now close. So you can see that if you zoom into Gauteng, for instance, zoom to layer, Gauteng, you can see now we have all the hospitals in Gauteng in yellow dots. So that means they have been selected. Even if we go to the hospitals under the layers list there, hospital, right click, and then we open attribute table. Okay. And then when we choose our under the show all features, let's choose show selected features. Okay. So you can see now it's only showing hospitals that are in Gauteng. Even if you try to set by ascending here, I can see Northwest there. As you may know that I think here is because it might be, it's what Carltonville Hospital. I think in the old database, it used to be under Northwest, but with new boundaries, it's falling under Gauteng. So you can start seeing and start picking issues from here to say, okay, let's zoom into that hospital and see what might be the case and so on. So now you are able to see your selected features from this aspect. Okay. Let's close here and go back. Oh, I ended up selecting the Carltonville one. I think it used to fall under Northwest, but with new boundaries, that area is Gauteng. Okay. Okay. Let me clear this one so that it has sort of like cleared my selection. Let's go back and redo it. First, select research tools, select by location, and then we want to select hospitals, correct, that are completely or that are within, okay, within which place or which layer within Gauteng layer. Then we choose Gauteng, and then we run our query, and then we close. So you see now they are in yellow again. It means they are now selected. So now we want to have a permanent layer or permanent shapefile that is called Gauteng hospitals. So we go to hospitals like we did with when we created Gauteng layer. We say export, and then we say save selected features as, and then shapefile, and then in terms of name, this one we want it under hospitals, say hospitals, and then we say Gauteng hospitals. And then we click save, and then we click OK. You can see now there are no more yellow like it was before. Okay. So because now we have created it as a layer, and it's also showing under our layers list there as Gauteng hospitals. Okay. But if we switch off here, we can still see our selection. So how do we ensure that we don't have selected features anymore? So under our toolbar there's that icon with some red, and then you deselect the features. So if we click that one, it will select, it will deselect all features that have been selected. Okay, let's click it so that we deselect this hospital in Gauteng. Okay, put it on again. So now you can see that even if we switch off the hospitals, you can see that we can still see some hospitals. So these are our Gauteng hospitals. We can even change the color if we want a different color for them. What color can we choose? This green. Okay. So these are our Gauteng hospitals. They're clearly visible. Okay. Maybe we can change our symbology there. Instead of that color fill, make it grayish to dark. Okay. And then you apply. And then okay. Any question? We can zoom to our provinces so that we see our bigger SA map. Any questions so far? Are you seeing any hand, Pina, or not?
There aren't any hand at the moment.
So it means we are all following, eh?
Yes, we'd
Hopefully.
like to assume that.
Yes, I hope I'm not leaving anyone behind. Eh?
I'm seeing one
Remember
thumbs up.
the census, we are saying no one should be left behind when we do the census
Yes.
counting. Yes, yes. Okay, colleagues. Our next step then is to learn how do we create a map out of this now, because now we have played with the data set, we have sort of explored this data set, tried to see how we can maneuver around and bring some insights in terms of, like, you know, if you want to see hospitals that are in Gauteng only, or if you want to focus only in one province. Same thing with district. You can just, if let's say your area is just one district, you can just go to the district layer and then choose the one that you are focusing on, either through location or through attribute table or by expression, for those who are, you know, into coding. Okay, so our next step is to create a map. So how do we create a map out of this exercise that we have just done? Okay, so for us to create a map, we have we have brought back the province zoom layer. Okay, for us to create a map, then we go to project and then new print layout. For us to create a map, we go to project and then new print layout, and then we click OK when this pops out. Okay. So we should be able to have this blank layout screen. Do you all have that, or should I go one step back? We go to project, new print layout, then OK. Then we have this blank layout. So this is where we are going to have our map. Okay. So for us to add the map, we go to add item and then click add map. And then we are going to track this cursor around where we want to draw the map. Okay. Can you see now our South African map is showing up? The map that we have there in our QGIS canvas. This map now is showing up in that layout. Okay. So we have our map showing up. So now we need to add more key features of the map, which are your, north arrow, scale bar, title, borderline, and all that. Okay. So that our map can look professional or ready for either publication or for inclusion in a report or in a journal article or even a book chapter per se. Okay. So then how do we add title? We follow the same process, add, then we say add label, and then we have to draw a rectangle where we want our title to be located. Okay. So as once you have done that, we can, right click do items properties there. And then we want to change the font size maybe to 20 so that it's more visible. Okay. Okay. And then we want to give it the title that we need here. We can just call it the test map. Okay. Okay. Now we have it there as the test map. And then you can even play around to say, in terms of, whether you want it centered or what, in terms of alignment, let's say center here. Okay. Okay. You can even have it under the frame if you need, if you feel necessary. Okay. That's our map title. And then what else we need? We need our north arrow. So we follow the same process. We are going to add north arrow. Where is north arrow? Then we choose north arrow. And then we can just throw where we need to add it. Let's add it here, north arrow. So now we have the north arrow. And then what else do we need other than the north arrow? Okay, we also need the scale bar. Then you say add, and then you say scale bar. And then we normally put it here, below here. Okay. So we have added the scale bar. What is missing? It doesn't have the legend. So let's add the legend, because the legend is key because it will indicate what are those features. Okay. We have now added the legend. Okay. Let's just right click here on the legend and then put some frame. Okay. Check frame. Okay. So our legend has frame. Let me drag it a bit so that it doesn't. Okay. It's not overlapping with the outer boundary of the map. Outer boundary of the layout. Okay. So what is missing? We also want some boundary so that we see where our map ends, because as it is. Okay, let's just go to main map and then look for the frame as well. Let's put in the frame there. Okay. So now we have our map with like the map title, the north arrow, the scale bar, and then the legend. Are we all here, or is there a step that maybe one could have missed? Are you seeing any hand, Tigdina?
There is a hand from, is it Nathan? Yes, but please go ahead.
Thanks. So this is for me just a general question, because my things just disappear. Is there like a back button that you can press? Because right now I had opened another layout, but yeah, my map just disappeared again. So I'm just wondering if ever that happens, because I think I've tried to use QGIS before and I kind of gave up because, you know, things just disappear on me. So I don't know, is there like a back button that you can always press when something happens?
If you click this one, they don't come back.
Mm.
Can you try it and see?
Is there anybody else that has a question
winning
or
or-
follow-up?
Oh, she's gone.
And she muted herself. She's
Sorry, yeah, I'm just gonna try again. Thanks.
Okay. Any other question?
There's a question from Mafunza. It's asking, how do I access HSRC GIS data?
Can you engage on that one at the end? But of course, it's through conducting us as the geospatial computing and analytics. So we can talk after this, or I can share my email. Okay.
Sorry, Tolang, just to let you know, there are 25 minutes left in the session.
Yes, no, I'm almost there.
Okay, sure.
Okay. So if no further question, I think then our next step is to say, now we have created this map. How do we ensure that now we have it either in a report or in a publication, or, you know, for those that are studying in a thesis or dissertation? So then our next step is to export this map to either export it as a JPEG or TIFF format or PDF. So you go to layout and then you say export as image or export as PDF. Let's first start exporting as image. So we click at export as image, okay, and layout 2. So we can give it a proper title here, test map, okay. And then you are saying JPEG format. Here you can even choose other format. For instance, you can choose TIFF, depending on the journal or the book that you are working with, because sometimes the editors, they have their own specific format that they will say. They'll say, no, we want JPEG format, or we want TIFF format, or we want PNG format. So this is where you can apply those different format and choose the one that is required. Let's choose the JPEG one for now, and then we click save. So now it gives you these options, because in most cases, because remember, for the publications or for the books, for the publishers, they normally have their own, you know, resolution requirements. In most cases, they will say, you know, we want it 300 dpi or more. So this is where you can adjust and, you know, make it to meet the requirements they need. And then you click OK. Okay, so now it says successfully exported layer to map. Okay, let's do the same for the PDF. We go to layout, and then we say export as PDF. And then we said we're calling it what? Test map. In this time, we said we want it as PDF format. So then we click save, and then we save. And then here it says it has successfully exported the PDF format. Then we go to our, where we are saving our files. In my case is C drive data. Okay. So now I have my two maps. I have the JPEG one. I can open it. Okay. So here is the JPEG map that I can copy and insert in the report or in a PowerPoint presentation or anywhere where I want it, or in a journal article. If I want the PDF one, I can go back and say the PDF, then I click PDF, and then there it is. So I think that's how you create a map, and then in this case you can just decide whether you want to keep it as PDF, depending on maybe it's for a client report. They say no, we want all maps in PDF format. Then you can just send them as a maps compilation in PDF format, or you can have them as a JPEG, depending on the in most cases, if it's more maps and you want to avoid the issue of size, we always save them as PDF, because the other ones, because they are image types, they are more often bigger in size. So you'll find that you'll have to find other sharing methods instead of just sending via email, because they might be too big for an email. So I think that's it in a nutshell, in terms of like how do you use GIS, and then how do you create maps and all that. And I think colleagues have sort of like gained some skills in terms of how to create a map. Yeah, so that's it from me. Unless if there's any question, I can stop sharing so that I can see.
Doc, we had the question from Mafunza, who was asking about how to access HSRC GIS data, since we are in the last sections of our sessions. Sorry, I'm not able to hear you on my side.
You're breaking up, Tolang. Perhaps if Emmanuel is still here, he could answer the question.
Yeah, we can't hear you, Tolang. For some reason, there are echoes. Sorry, can you repeat the question?
The question was, how do I access HSRC GIS data?
Okay, so if you go to the HSRC website, there's a portal where it asks you to fill in details and the required information which you want specifically. If it's GIS datasets, I'll just share the link in the chat. So you can like request, and then your request will be reviewed, and then they will communicate on how you can access the datasets which are available. So I'm going to share the link just now.
Thank you for answering that question. Then we have another hand from Muzama. Could you please speak?
Okay, My question is that in case you go into the field and collect data, for instance, I work on ticks, the insect, the parasite. So we go to different farms and we go to specific areas. Sometimes it might be maybe in a deserted areas where we look for ticks. So when we want to then put that data in to say this is where we collected those ticks, we have the GPS coordinates. How do we then do that, incorporate that in a map where I just want to show where I collected the ticks using my GPS coordinates?
Sorry, so there's a process of geocoding where your data set will, for instance, if you have collected locations and you have X and Y coordinates and then you populate them in an Excel format, there is an option on the ArcGIS software where you can import such external data set, which is non-GIS, so it's non-spatial. And there is a quick way of just geocoding where you can convert these coordinates into GIS vector format. So you just say geocoding on QGIS. I think Tolania didn't complete that part for this exercise, but we did demonstrate last year. However, there is a process where you just geocode on QGIS.
So it's more of conversion of my
Yeah,
GPS coordinates to.
yes. So you just input the Excel into GIS, into a QGIS, and then you convert. So it's just like a easy process, really.
Okay, maybe perhaps because I do not know, I'm just trying to figure it out. The Excel sheet also should contain maybe columns that has the place, which is
Yes.
maybe
So
the name to
so you have
identify it, and
so
latitude. Okay, or you can go on.
Yeah. So no, I was just adding on as you were asking the question. So you have rows and columns, Excel. So you have rows, they probably it's point 1, 2, 3, 4 under the rows, and then columns you have X, that is latitude, and then Y column. Then when you present that data set in an Excel, I'm not sure. Yeah, I think Dr. T is just trying to illustrate. Yeah, Tolang, I think just go ahead because you can't you are not that audible. So just illustrate quickly if you have an data set.
Dr. T, we can't see your screen anymore, and we still aren't able to hear you. But we do have another question from Sisa Senkosi. The question is, what are some examples of practical use cases for GIS in the social sciences to see how else it can be used? I think Dr. Emmanuel's, could you please take that? Because I think Dr. Tulang is still having issues with audio.
So in the social science space where you have demography information, let's say you go out and you compute a survey on how people in this community are disgruntled in terms of certain government service delivery. So you have this information on where these individuals are located in a particular municipality and which grievances they have as per how you've designed your survey. Then above and beyond what you would have collected in the survey, you can create models by doing correlation, like a geographic weighted regression, where you say, is there a causality of space in terms of location where these people are staying and certain ailments or certain grievances to these issues? So that's one example in service delivery. And then you can also look at epidemiology cases where you look at the prevalence of certain diseases. Then you can geolocate these areas, and then it can inform decision makers, especially to see which areas are underserviced. You can also look at another practical case where you overlay different GIS or remote sensing datasets again in space, and then you find where individuals are located and the problems which they are facing. So you can compute geostatistical analysis where you do, in the sense of inferred statistics, to say, okay, in these locations, people are having these issues. Is it location specific or it is not? So yeah, those are some of the cases.
Hi, Emmanuel.
Yes, and also contact tracing. You see what happened with COVID-19, where they could actually geolocate where you stay, and then they can say, if you want to have a COVID vaccine shot, this is your nearest center point to go and get vaccines. So they can you can find people's locations and the sources of certain services. Then you can do the cost distance analysis to say, go to the area which is in close proximity to you. Yes.
Thank you. I just wanted to give another example from work that I've done. And then I believe you have a Mentimeter to share. But just quickly, so we use GIS a map for the National Science Week, which is undertaken each year, and we wanted to see which schools had participated in the activities, where they were located, and then it was also the data that was included was the socioeconomic risk index. So to see how many of the schools were from areas that were disadvantaged. So that's also something you can do. You can map schools, you can map hospitals, you can map a lot of different spaces. So that was really useful as well. Thanks. Yeah, so Emmanuel, I believe you have a Mentimeter to share with the participants.
Yes, I had shared earlier. Let me just share again. I'm just going to drop it on the chats. So it's just less than a minute to complete. It's not a long survey.
No, that's fine. So if you can all please go to Mentimeter, and Emmanuel will share the link now in the chat. And I see Bongi has also shared another example of how GIS can be used in the social sciences. And if you have a look in the chat, there's a link.
And before we finish off, I'd like to remind everyone who has attended this session to please complete the evaluation survey link. I'll send it once again in the chat.
Thank you. Emmanuel, will you share your screen to show the Mentimeter results?
Okay,
And for the Mentimeter, is there a specific code that participants need to put in?
There isn't a code on my end, so you just click on the link and then you
Go straight.
answer.
oh yeah, I'm
then you
muted.
answer the question.
Okay, perfect. Would you like to share your screen to show the results as they come in?
Yeah, I will do so just now.
Great. Okay, so then you can just click on the link, the Mentimeter link that I've shared in the chat. You don't need a code, it will take you straight to the questions.
Hello, can you see my screen?
Yes, we can.
Okay. Thanks. I think people are still populating or responding to the comments, so we'll just have to monitor the Mentimeter platform.
Dr. Emmanuel, someone in the chat saying they are waiting to answer the next slides on the Mentimeter. So I think you need to change the slides on your end.
Yeah, okay, I'll do so.
And you're also not sharing your screen anymore. If you could reshare so we could see the results. There we go. We can see your screen again. Yeah, I'm not sure. It doesn't seem, well, it's not showing any responses so far.
Yeah, it's not
So
put. Yeah.
yeah, maybe part of the participants, if you would like to just share your responses to the question in the chat, perhaps there's an issue with Mentimeter, but maybe just put your answers in the chat. There are some at least responses that have come through for the first question.
For us, it says, please wait for the presenter to change slides.
Yeah, I did change. For some reason, it's
not showing.
Yeah.
Okay, maybe for the second two questions, we can just get some responses in the chat. I see there are a few people who have said no. One person has said yes. Okay, so there seems to be a mixture. Some people have used software before, some others haven't. Okay, and then would you like them to answer this question that's on the screen?
Yeah, if they can, but yeah.
Okay. Okay, so maybe just in the chat, tell us what your key takeaway was from today's session. I'm not seeing any responses yet, but we'll give it a couple of minutes. Okay, practice makes perfect. Help them understand GIS much better. Attribute statistics. They can play around with the data set to answer their research questions. How relatively straightforward it is to make maps once the data is there. Creating a map. Okay, so there's some key learnings from today's session. QGIS is an essential tool for research. More practice is needed to become well-grounded in its use. QGIS can do more than I thought. That I can also do it. It's not as complex as I thought. Introduction to GIS and need to play around with the data. Great, those are some really nice answers. Emmanuel, was there another question you wanted an answer to? Emmanuel, you're muted.
No. So the other question was, do you think you can now apply GIS into your research after this exercise?
Okay. Okay, let's get a couple of answers in the chat to that. So has the session helped you to be able to use QGIS in your research? Yes. It's an essential tool, but they need more practice, certainly. Okay, so yes, it seems that quite a few participants have learned how they can apply it in their research, and they're feeling a bit more confident to try it again on their own. Some people still say they need some more guidance and practice on using it, but they would like to use it in their research. Great. Okay. I think we can start wrapping up the session. Dr. Fundisi, Dr. Mokele is having some issues. So Dr. Fundisi, if there's any closing comments you would like to make just to summarize the session, or any other thoughts?
Well, just to take this opportunity to thank the participants in taking their time to pay attention to the practical session. Sometimes it can be cumbersome and difficult to follow, and sometimes when you're being introduced to a new technology, you can easily get swayed off. So yeah, a big thumbs up for those participants who managed to be there until the end. And again, feel free to reach us at HSRC at the e-research knowledge unit if you have any questions and if you would want to access datasets, and also in various research which you are involved in. If you need assistance, so you can just feel free to contact us.
Great, thank you so much. Dr. Mokele, I'm not sure if you have any last comments.
No, thanks very much. Can you hear me?
Yes, we can hear you now.
Yeah, I don't know what could have happened. Thanks very much for your attendance, colleagues, and for for those questions and comments that came through. And we are glad that most of you are saying going forward you'll be able to use GIS in your research areas and projects. So I think it was an interesting session, and we are glad that we have imparted some knowledge somehow in this session. And thank you very much, Sylvia, Tina, and other colleagues who made sure that this was successful. Maxwell as well, and Moses from the IT. Thank you very much, colleagues. Thank you.
Right, thank you so much. Thank you to Dr. Fundisi and Dr. Mokele for a really interesting session. I think the participants really did learn a lot. And remember that all of the information will be available in the repository, as well as a recording of the session. So if you would like to go back and follow through the process again and try different things, the recording will be made available. But thank you for a really great session. Thank you to our technical facilitator for keeping us on track and keeping track of all the questions. And thank you to Maxwell for your assistance. And I hope you really all enjoyed the session and learned something. And thank you so much for attending. Enjoy your afternoon. Goodbye.
Bye-bye.
Bye all. Thank you.